Okay, I can see from our screens that we're now live streaming on YouTube, so let's go on the record. Good morning. Today is the second day of remote evidentiary hearings being held in Energy Facilities Siting Board docket EFSB 20-01, D.P.U 20-56, and D.P.U 20-57. We are continuing today with questioning on the topics that were originally designated to wrap up last Friday. Since we haven't, we are going to begin with those remaining topics today and hopefully progress through them. Mr. Gerson, did you have any other preliminary matters before we turn to questioning from the bench?
I don't think so at this time.
Okay, thank you. In that case, Ms. Yellen, you have questions for the witnesses this morning?
Yes. Good morning.
Hey.
Friday, I know we discussed cable capacity, the cable capacity selection process in some detail, but I'd like to discuss it in a bit more detail. Can the company please describe and provide an overview of the types of electrical or other studies it conducted to help it arrive at the conclusion that a 275 kV cable capacity was optimum?
Sure, I can start that, and then probably Mr. Arruda will add to it. So I think we did touch on some aspects of this last week, but the basic studies in this case were to look at the merits of a 220 kV cable, which was the cable capacity that was selected for Vineyard Wind 1. And then for this project, we also looked at a higher voltage 275 kV cable. So there are far more similarities between the two cables than there are differences. They're both solid dielectric construction. If you looked at a cross section of the two, they look physically quite similar. Although the 275 kV cable, because it is a higher voltage, can operate at a slightly lower amperage and carry the same power. So the conductor can be a little smaller. And on the other hand, because the voltage is higher, the insulating layer is a little thicker or heavier. But both of them have the same kinds of shielding layers. They both have an armor cable wrap and an outer jacket, et cetera, et cetera. So they're quite similar in construction. The 275 kV cable is a little more flexible and a little lighter, so it's easier to work with in installing it. And that's particularly the case for the land side segments. And because it is a little lighter, you can put a little more of it on a cable reel, which may translate to the ability to have greater distances between the splice wall, kind of an incidental benefit, not a big driver of this. So,
I'm sorry, not a big driver of this, or it is?
Not a big driver. Sorry. So it's sort of those basics. The assessment and the work that the company did to look at this, then really looked at the state of the marketplace. Is the technology and the cable available from leading manufacturers? Has it moved to a point where 275 kV cable is in fact available for this kind of an application? We think the threshold answer to that was yes. And then there were a series of electrical studies done. So basically looking at the length of the cable for this project, which is somewhat longer than Vineyard 1, because the wind area is much further offshore. And then basically looked at the power output, the load flow through the cables, the reactive currents, the heat dissipation, and some other factors. And basically, when the company was done with that, the conclusion was reached that in this case, the 275 kV cable was the more effective choice for this. Now, I should note, and we answered this in one or another of the interrogatories, that we expect the initial cost of the 275 kV cable to be slightly higher than that of the 220, but because of its improved electrical efficiency over the life of the project, we think we will make that up and then some in savings in lost energy.
I'm sorry, in savings what?
Savings in lost energy. So that's the gist of what we went through, without getting into the specifics of the electrical engineering. In both cases, the 220 and the 275 kV cable can work for this application without the need for any midstream reactive compensation station, which could potentially become a concern as you go to longer cable, but in this case, not. So I'll stop there. And Jack, do you have anything you want to add to that?
No, I think you captured the high points and the most important parts of it. As Mr. Barton said, the load flow and the ampacity calcs are the key drivers, though. And along the route, they will, some of the critical points are the burial depth of the cable, and the burial depth at your HDD, your shore landing, becomes a lot of time kind of that pinch point for the cable sizing, because that's the deepest part of the route normally. And that is where, with the 220 kV, you get into some limitations because of the HDD, where the 275 gets you over that hump at that deep at the HDD location. So that's also a key driver in going from the 220 to the 275. But as Mr. Barton said, it's all, at the end of the day, it's the ampacity, but it's also balancing the overall electrical design with the offsetting shunt reactors on each end of the cable and managing the voltage profile over the whole cable during varying load points for the project.
Thank you. So I am new, so I am just curious. Help me understand why a 220 kV cable and a 275 kV cable, at the time that the company wrote the petition wrote the analysis, was what the 275 kV cable was available on the market at that time, correct?
In the U.S. projects that are proceeding through permitting, the first project, Vineyard Wind 1, as I said, used 220 kV. The Mayflower project, which is proceeding more or less in parallel with Vineyard Wind 2, has announced that they're going to use the 275 kV cable. So the manufacturers had that as an offering. It had not been actually put in the water, as is the case on some European projects for the 220 kV cable. So we felt the reason we had both of them in the initial petition was we could see the cable technology advancing. We knew there were some potential advantages, as we just discussed, to the higher voltage cable. So we wanted to have the option to look at that more carefully, which in fact is exactly what we've done in the year plus since the petition was filed. And that's why we're now at a point where we can say we do plan to use the 275 kV cable.
Okay, thank you. And yeah, I'm curious. Why globally, why does the company think that globally there is a trend to move towards a higher capacity voltage cable? Where is that trend? What's indicated there?
So I think some of the the same things that I covered in my sort of overview. So the projects are getting bigger. At one time, a 400 megawatt wind project was considered big. 800 is now kind of a standard. If there's such a thing as a standard size, that's probably it. And some people are proposing larger projects, 1,200, 1,500 megawatt. So there's an interest in using the highest capacity cable so that you can minimize the number of cables for a given project. Now, that's really not an issue here for 800 megawatts, where we would use two 220 kV cables or two 275 kV cables. But then there's also the driver of efficiency, cost, the electrical performance, some of the things that Jack just covered. So pretty much every developer will be looking at those kinds of things. And as the technology advances and improves, you want to be able to take advantage of the most efficient solution.
I'm sorry, the most efficient what?
Solution.
Thank you.
Mr. Barton, John Young here, and maybe Mr. Aruda knows the answer to this more, but given that direction, is the industry likely to have a 345 cable, or a cable that could run at 345 anytime in the future that would match up with some of the New England grid?
Well, that's a good question, and we did touch on that in one or another of the information requests. And to our knowledge, such a cable is not available or being contemplated at this moment in time. Might that be possible at some point in the future? Yes, but at what point in the future? I don't really think we hazard a guess at that.
Is it a real technical challenge to carry the higher voltage, or it just isn't the market's not doesn't look like it would support it, and so nobody's trying to make it?
I think that's probably a question that's better aimed at a cable manufacturer. I just think it's early in the process. The industry's just starting to move to 275, and I think that's going to take a while to settle out, get those cables in the water, and then at some point, is it possible that things will move past that? Yes, but I really don't think we have any specific intel on that beyond what we've already said.
And then any of the panelists, again, is it almost all the offshore wind market that's driving this, or like in Europe, you have a lot of countries that have water in between them, and there seems to be a fair amount of there's a fair amount of undersea connections there, more so than in the U.S. Is it the same market for the for cables in between different land masses as it is for the offshore wind industry?
So that's a good question, and to my knowledge, the long distance cables that run from country to country, not only in Europe but other parts of the world as well, that's basically the domain of the HVDC system. So HVDC cabling with converter stations at either end. That's a fairly different a fairly different cable setup.
And so even the cables are different between AC and DC. They're built a little different.
Yeah, because of the fundamental difference in the current that they're carrying.
Great, thanks very much.
Sure.
The company mentioned, cost and inefficiencies. What are other, or just help me understand a little bit more about the disadvantages of using a higher voltage cable capacity?
So I can maybe take a little bit of this one, Ted, if you'd like.
Sure.
So while you would intuitively think that the higher voltage, if the higher voltage cable is available to you, would automatically want to go to the higher voltage, but it really is specific and overall electrical design specific. A project that is closer to shore may choose the lower voltage cable because the higher the voltage, the higher the charging currents. The higher the charging currents, the more you have to offset those charging currents with the reactors on each end of the cable. And at some point, those reactors can get so large on each end of the cable, it makes the switching of the cables in and out and managing those much more difficult. So it's really project specific as to which voltage you would choose, even if the higher voltages were available, because of the varying electrical aspect of the project.
And
Okay.
kind of a good, if I could just add a good example of that, this is sort of at the smaller end of the project scale, is the Southport project, which is in home review. That's a project that's connected to the eastern end of Long Island, 130 megawatt project. They plan to use a 138 kV, which happens to be the voltage that is in the system at that end of Long Island. So it's a good match for that.
I'm sorry, so it's a good match for what?
For that smaller project.
Okay, so there's nothing there. There's, from what I'm understanding, there's nothing that's outrightly a disadvantage of using a higher voltage.
The disadvantage would be is you had a very long cable system at the higher voltage, you have the higher charging currents, and that will drive the size of the offsetting reactors on each end, the shunt reactors on each end of the cable. At some point, you may not be able to size those reactors on each end appropriately and end up with a much higher voltage at the center of the cable that you can manage. And that goes to Mr. Barton's earlier point where you might need a midpoint reactor station if you stay with the higher voltage AC. There's definitely some advantages to the higher voltage, but it's really kind of project specific and length of cable to shore, where you do the overall load flow, manage the voltage profile over that cable, and see what makes the most sense for that project.
Okay. And from an environmental impact perspective, I know the company touched on this a bit in their information requests and their information responses. With the higher voltage as a selection, 275 kV, can the company elaborate on, are there greater environmental impacts based on this selection? Are there the same? If I could just get a bit of information there.
Sure. So as I mentioned a few minutes ago, the physical size of the cable is quite similar, although the 275 kV cable is a little bit lighter. So in terms of, and there are two cables with either voltage. So the physical installation process for the cable, at least the submarine piece of it, is not significantly different. You would not expect to see any real differences in temporary sediment disturbance or anything like that arises from the installation. It's minor in either case. On land, as I mentioned, the slightly lighter, more flexible cable might allow you to space the splice faults a little bit further apart. So it's a small difference, but an advantage. And then on the EMF front, we did do, at the siting board's request, some specific modeling of the higher voltage cable. And the results of that are in information request MF15. And basically what that showed was that the expected magnetic field from the higher voltage cable, because it operates at a slightly lower amperage, was slightly less. In both cases, the levels are far below the applicable health-based guidelines, but there is a small edge, if you will, for the higher voltage cable on that front. other than that, I don't think there are any appreciable differences from an environmental perspective.
Thank you. That concludes my questions on the cable capacity selection process. Do my colleagues have any additional questions on this topic?
Yeah, I had a quick follow-up on something Mr. Aruda said about the difference in the HDD construction between the 220 and 275. I think you described the depth of cover and something like a pinch point, and I was hoping you could elaborate a little bit more on maybe why a 275 is preferable from an HDD perspective.
Sure. So the HDD itself doesn't change much as far as the design of the HDD. It's just that all HDD characteristically, you have a much deeper burial depth than you would in the normal jet plow installation coming from the wind farm in. That shore landing, you could end up, 35, 40 feet below the seabed. And that is usually a critical point for cable design because it's harder to dissipate the heat from the cable the deeper it's buried. So that's what causes you to reach your maximum allowable temperatures of the core of the cable sooner at those deeper burial depths. So in a case like Vineyard Wind 2 that we're speaking to here, the 220 may have reached its limits before you could carry the full output of the project at that location without maybe stepping up to a much larger cable different from the rest of the route. So it's a balancing act between cable losses at that point, and going to the higher voltage allowed you to get that lower ampacity for the same generation at that burial depth in the HDD. So the 275 works well for this particular project at that point.
Thank you. That helps me understand. I think Mr. Barton indicated that a 275 cable is actually a little bit lighter and a little bit more flexible than a 275. Is that correct?
I did say that, yes.
That seems like intuitively kind of confusing to me. I would think a 275 cable might have a little bit more metal in each conductor and be actually heavier and less flexible.
Actually goes the other way. So the higher the voltage, the lower the current can be to carry the same power. And as a result, the higher voltage cables have a smaller copper or aluminum core. They do have a little more insulation, but the insulation is lighter in weight. So the combination of the two gives you a slightly lighter cable for the higher voltage.
Mr. Hazel, you said a wrong number the way you asked the question, but in any case, Mr. Barton, the 275, the cable that's for 275 kV is lighter, has less metal in it than the cable for 220, correct?
Correct.
Thank you. I'm all set.
If I could just jump in quickly. I just want to make sure we have on the record what the megawatt carrying capacity is for these two varieties of cable in a standard specification sense.
So these the magnetic field studies, for example, that I mentioned earlier, we looked at the full output of the project. And I don't have the ampacity numbers committed to memory, but basically each cable can carry 402 megawatts, and that's what we studied. Now, I'm sure there's a little bit of excess, and Jack may be able to speak to that, but these are full capacity cables for the wind farm as designed.
Right, and I understand they can carry the wind farm capacity. I'm just wondering, as a specification matter, what the maximum carrying capacity is of each cable type in megawatts.
Okay, so we might we might need to do that as a record request, and make sure we get you the right number from the specs as they're written.
That would be fine.
And Mr. Green, is your question for a specific size cable at a specific voltage, what that maximum power that cable could carry, or is it specific to the Vineyard Wind 2 project, what the cable has been sized for?
Let's make it specific to the Vineyard Wind cable choice between the 220 and the 275. I realize that the wind farm has a certain amount of intended capacity. I'm just looking for what the getaway capability is, as it's sometimes called, for these two cable types, in terms of the maximum amount of megawatts they could carry with the configuration that's available for this project, if you follow my question. In other words, don't limit it to the size of the wind farm. I'm really interested in how the cables would be operated for this project and what the respective megawatt carrying capacities could be.
Yeah, we can get you that load flow information that the cables were designed for.
I'm sorry, we can get you that load flow information. What?
That the cable circuits were designed for.
Mr. Arruda, the way you rephrased the question, I don't know if that's quite what Mr. Green was asking for. I think the question, and then this is maybe my version of the question, how much, if you imagined having a larger wind farm out there, how much current could these particular cables carry? My sub question is that limited by the depth of is the capacity of the cables dependent exactly on the depth of the HDD at the coast? And how much could they carry without overheating, if you did have more power that you could carry on them?
Right. No, that was my intention to get that answer as you just rephrased it, because the HDD location is probably the critical point, which gives you the ultimate size or generation carrying capability of these cables are limited by that HDD location and potentially out at the offshore substation too, where they come out of the water and go up through the J tubes. So we'll get that information, and that'll tell you the maximum megawatts that could be carried on our cable configuration.
That makes sense to me. Does that make sense to you, Mr. Green?
Yes, that's a helpful clarification. I appreciate that.
All right, thanks.
And that's it for me.
With that refinement, that will be record request EFSB 14.
Moving on to a couple questions about the proposed substation. Is it correct that the substation design presented in the newly filed exhibit VW-10 is based on a 275 kV cable?
It is.
Okay. Are there different substation equipment required for a 275 cable capacity compared to a 220 kV?
So the basic guts of the substation are the same types of equipment. So they're transformers, they're reactors, the switchgear, all of the individual pieces that make up the design of the substation were there when we had a 220 design, and they're there for the 275 kV design. But at 275 kV, all of the equipment is specifically rated for that voltage and sized for that voltage. And for example, the incoming step-up transformers were for the 220 design. They would have to step up the voltage from 220 to 345. Now they step up the voltage from 275 to 345. So there are some internal or rating differences in the equipment. If you stood on the ground and looked at it, you likely would not would not be able to tell the difference. But there are some refinements that go into the design for the 275 kV spec.
Okay, so there's an engineering electrical differences, that are changing, but the equipment itself is not changing.
Correct.
Okay, thank you. Do any of my colleagues have any further questions on this particular topic? Okay. Please explain how the updated substation design accounts for the increase in cable voltage. You mentioned that, but is there anything about the design that is incorporating anything else other than those, what you just are describing about the engineering design? Is there anything else that the substation has to account for?
Not to my knowledge, but Jack may be able to elaborate on a subtlety or two. But as I said, the basic equipment complement is the same. The incoming duct bank for the 275 kV cable, the underground duct bank that comes in on the right of way and then runs up the east side of the substation is physically the same as it would have been for a 220, but it has 275 kV cable in it, not 220 kV. But other than that, I don't believe so. Jack, anything you would add to that?
No, that's correct. The actual equipment, number of pieces, all that stays the same. It's just the rating of the actual equipment.
And I certainly am not an electrical engineer, so I am just curious. Is the updated design of the proposed substation, the newly updated proposed substation design, is that at all influenced by the increased cable capacity selection?
In a word,
I'm sorry, I didn't hear the end of the question.
I wanted to clarify what I was saying is that the design decision, was the decision influenced by the 275 cable selection?
Basically, no. So the fundamental drivers for the substation are the functions that it needs to accomplish, which is basically to step up the voltage from 275 to 345, and then take that 345 kV power over to the interconnection point. As we described in the petition and some of the IRs, because of the size of the site and the amount of equipment, the design is a gas insulated substation as opposed to a more expansive air insulated substation. More expansive takes more space. So those were sort of the fundamental drivers, and then the rest of the layout is a function of having the equipment sort of in an orderly fashion, and then paying attention to the off-site noise, the visual characteristics, and that kind of thing. But the cable voltage really is not a factor in that.
And if I might add, just specific to Exhibit VW-10 and the revised site layout, cable voltage was also not a driving factor.
I'm sorry, what voltage was not?
The cable voltage was also not a driving factor in the decision to present that revised site layout. Rather, the driving factors were to improve site access, as well as to minimize the amount of fill that needed to be brought to the site.
Thank you. I'm switching gears a little bit away from the proposed substation. This question, my next few questions relate to EFSB-PA-6, if you'd like to turn to that. The company indicates that it intends to file with ISO New England the proposed KV change in 2022. Is there an actual requirement from the ISO New England that states the company must file the proposed change?
I can take this. So, yeah, if you make any changes to your project design that were not studied in the original system impact study, you need to go back to the ISO with an analysis of those changes, and it's considered a material modification determination. That's the process. And provide them enough analysis, and then they will do their own analysis to confirm that your proposed changes perform as good, if not better, than what was originally studied in the system impact study and have no impact on other future studied projects. Then they'll deem it not material. So that's a process that you have to go through for any of the changes that we may make in the future to the project's design that was different than what was originally studied in the system impact study.
Thank you. What is the actual filing called? What is this notification that the company must say and send to the ISO New England called? What is that actually called?
A material modification determination.
And what is the status of the filing at this point?
We have not prepared the filing at this point because you'd like to evaluate the whole project and then go in with one package for them to review versus, all individual, because you really want to make it as efficient as you possibly can for the ISO to review any changes that you make to the design.
So when does the company anticipate to file with the ISO?
As it states in the IR, the plan would be probably in 2022 for that to occur. A lot of that decision making comes along the lines of the actual wind turbines, because the wind turbines obviously are the critical, one of the key critical components in all of your system impact study that occurred. So any changes to the wind turbines themselves, you would need to submit that to the ISO for review.
Okay. Let's talk about the material modification request in EFSB PA6. That's a little different. That's the material modification request is different from the material modification notification filing, correct? Is that correct?
No, that's all the same. It might just be the words. You basically will request at the ISO. You'd say to them, we're going to put in a material modification determination package for the ISO's review. And I mean, that's really what it falls under, is that portion of the tariff. It's a material modification determination. And you always hope that the ISO comes back and deems it not.
I'm sorry, you always hope that the ISO comes back
and deems it not material.
Okay, thank you. And just for the record, can the company define what a material modification request is and how it relates to the company's system impact study completed with ISO New England?
What it is the actual analysis that takes place for any changes that you do make to your project that were not originally studied in your system impact study and approved under the I-39 process of the ISO tariff.
Okay.
Mr. Arruda, do you have an estimate of the change in the potential permitting schedule that might be related to the need to file a request for a material modification review from the ISO?
I'll defer to my colleagues, but the ISO material modification process is not connected to the permitting process as in any way that I'm aware of. I mean, other than, no, it really, the ISO process is a separate process.
Well, can you tell me the potential change it might take in your overall project schedule then? In other words, how long does it take them to complete the review?
Oh, I apologize. The ISO under their tariff has, once you submit the package for determination, they have 10 business days to review your material modification package and provide you feedback. They do have some discretion there because it's not necessarily 10 calendar type days. It can be the equivalent of 10 days worth of work to review the package that you've submitted. If what you're asking them to review would undertake a lot longer time for their review, then it could be deemed material just because of the orders of magnitude. So that's why it's very critical that the package you submit to the ISO is very thorough and comprehensive, and it answers all the questions that you would expect they would possibly ask about the change you're making. And Vineyard Wind has experience in this area, working with the ISO.
Thank you, Mr. Arruda. Sorry, Ms. Yellen.
It's quite all right. So, okay, so the 275 kV cable decision, that selection does constitute as a material modification according to the ISO, correct?
Well, we would, just to clarify, we would want them to deem it not material because it shouldn't be material, but we would have to present them with the changes that we've gone to from the 220 to 275 because 275 wasn't initially studied under the system impact study. So we would submit that change as part of any other changes we make to the electrical design.
Okay. So once the company submits the notification of the proposed change to ISO New England, can the company please send that to the board? This might be best formatted in a record request. I'm not certain. But along with that, can the company please send the board the ISO New England's response to the company's notification? Again, this might be best formatted in a record request.
So as record request EFSB 15, the siting board is requesting a copy of both the company's filing with the ISO on its potential material modification to its original design, as well as the response from the ISO regarding the design that you have submitted.
Presiding officer, if I may, I don't think we'd have an objection to providing that. That would be fine. But I do believe the witness said that would be in 2022. So we can take it as a record request if that's the way you think it's most efficient to handle that. But it strikes me that the timing is very likely to be quite different than for a normal record request.
Yes, Mr. Gerson, I was assuming that the company would not, for example, be able to provide a response within the next 5 days. However, usually if we make a record request, and as I'm sure we're addressed in Ms. Cedar's original procedural rules, the company is required to provide a response to any outstanding requests, and they will become part of the record in this proceeding if in fact, for example, a decision was not rendered by the board prior to the submission of that response.
Certainly, we can take it as a record request. Just wanted to make sure everyone understood the time.
Thank you, Mr. Gerson.
That concludes my questions on material modification requests. Do my colleagues have any further questions on this topic?
I have a quick follow-up question for Mr. Arruda. Could you explain what would happen if the ISO determines that this is a material change?
If it was deemed material, then you would have to file a new Q position for if you insisted on staying with the changes that you proposed. As I said previously, in this particular case, this is pretty de minimis. We would not foresee a 275 kV generally being considered material because will be we could easily demonstrate that it has no material impact on what was originally studied, and that the performance of the wind farm will be as good, if not better, than what was originally studied. That's kind of the threshold criteria, and changing the voltage of the gen lead, as long as the
I'm sorry, changing the voltage of the,
on the generation lead, or cabling coming from the wind farm, as long as the rest of the design takes that all into account, which we'll have to demonstrate through analysis, this is really a pretty small request, in my opinion.
And it sounds like one of the reasons the company is waiting until 2022 is because there might be other design changes that you would bundle up into the same material modification request.
Yes, exactly.
And it sounds like your expectation must be that any other change would be similarly de minimis.
Yes, we're very confident that any changes we would make would result in actually better performance than what was previously studied, or we obviously wouldn't be requesting such a change. So that would be the thought process.
And hypothetically, if it was a material modification and the company needed to get a new queue position, like you said, what would that involve?
It would involve refiling, but you have the ability to actually withdraw your request if it's going to be deemed material. It's a dialogue that you do have with the ISO, and again, we wouldn't submit a package that we felt didn't demonstrate that we had as good, if not better, performance than what was originally studied.
Okay. Thank you. That answers my questions.
I'm now going to move towards some questioning about
excuse me. Just one follow up on that. Mr. Arruda, you referred to performance that was better. Use the word better, how ISO would think the wind farm was better. What does better mean in that context?
Well, as the technology evolves here, your wind turbine technology is changing pretty rapidly at this point in the industry. So you could end up with wind turbine. A lot of the ISO process is driven by the quality of the electrical models that you have at the time of your submission of your interconnect request, and they start the system impact study. These models are maturing over time. So a lot of these electrical models will get better with time and actually show better performance than what you could originally demonstrate in some of the stability analysis and other analysis.
But Mr. Arruda, when you say better performance, what would the ISO consider better? You mean more megawatts production, or a better, or a smoother power quality, or what would offend them as bad performance from a offshore wind turbine? Maybe that's a better way to ask the question.
No, I think you said it better, smoother performance. So a lot of the study analysis, we cannot increase the megawatts per what was originally studied. That's one of the criteria of a material modification. But a lot of the analysis that goes on in your system impact study is a lot of the stability analysis. How does your wind farm perform during certain contingency situations? Faults on the system, loss of lines, things like that. So it's how quickly the project responds in compliance with the rules of the ISO. And those are the things that would probably be enhanced over time with this modeling, becoming more granular as time goes on. I mean, the models are good now, but they're only getting better,
So for instance, you would tend to predict that a 275 cable would not be more unstable than a 220 as far as the wind farm upsetting the rest of the grid. Is that an example of the kind of thing that you don't think would be worse, and therefore it would not be a material change?
Exactly. There should be no different. The 275 should have no impact on the performance of the wind farm.
Thank you. I muted myself. Thank you.
For my next set of questions, I'm largely referring to Exhibit VW-1 at 3-4 and 3-5. For Vineyard Wind 1 and Vineyard Wind 2, the company selected AC technology for its transmission cables. Please elaborate on why the AC technology was the preferred technology.
Excuse me, could you just please repeat the page site you're looking at?
VW-1 at 3-4.
So, so basically we went with AC technology in this case because we have a wind farm that is situated roughly 50 miles off the coast, and we have a substation that we want to interconnect to about 4 to 5 miles inland. So at that distance, the power transmission can be very ably done by proven AC technology. And that's not to say that you couldn't accomplish the same thing using an HVDC setup, but if you went to HVDC, you would add 2 large, expensive converter stations, one out at the wind farm to convert the AC output of the wind farm to DC, and then another big converter station somewhere near the interconnection point where you would convert the DC power back to AC. So those add a lot of cost to the system. And it's just simply not needed in this case, given the location and the scale of the project. So the 2 roughly 400 megawatt AC cables that we've selected do a perfectly fine job and do so at a considerably lower cost than an HVDC solution would entail. So that's the fundamental reason.
Okay. On Friday, Ms. Johnston, I'm not sure if I understood you perfectly. I think you mentioned that there might be environmental concerns if the company were to switch from AC cables that are proposed in Vineyard Wind 1 to DC cables. Am I interpreting any of that correctly? Would there be any environmental concerns using DC cables now for Vineyard Wind 2 when AC cables were the selected technology for Vineyard Wind 1?
So I believe my comment from Friday in terms of potential environmental differences switching from AC to DC was really specifically referencing the converter stations that are necessary on either side of a DC cable system. So you would need a converter station in the offshore as well as in the onshore. So the additional infrastructure would obviously have some further impact on either side of the project. What exactly that further impact would be would obviously be based on the actual design of those converter stations and the precise locations of them.
Thank you. Are there any studies conducted to confirm that AC technology is still the preferred preference? I'm sort of trying to understand why the company selected AC technology again, from a studies perspective. Was there anything that the company conducted to confirm that this was again the correct choice?
So let me start that, and Jack might want to add to it. I think that this decision falls to some extent in the common knowledge category, where given the location and size of the wind farm, given our target interconnection substation, the distance involved, it was very clear that AC would do a perfectly fine job in this case. So hence there was really not a need to do a sophisticated study to compare that to HVDC, because we know from other experience that the HVDC system adds a great deal of cost to the effort, and as a company, Vineyard Wind certainly has some experience with that, in that confidential bids that have been made into other power markets because of their distance have relied on HVDC technology. And in the course of putting those bids together, the company had occasion to look at the higher cost of that system. Jack, I don't know if you want to elaborate on that a little bit.
No, those are the key points. I mean, at the end of the day, if you can design the system with AC, you're going to use AC most all the time, because it is the most cost-effective way to interconnect the project. And the DC converter stations, as Ms. Johnson said, are very large. They're very complicated. They're very expensive, and they take a long time to build. So there's schedule impacts, cost impacts. They have their place, but if your wind farm is in a proximity where you can build it and connect it to the transmission system with AC, that's going to be the preference.
Thank you. In Vineyard Wind -1 at 3-6, the company mentions that AC cables have proven to be technically sound and an economic solution. Can the company just elaborate a bit on what that actually means, what it means to be technically sound and an economic solution?
So I think the point we're trying to make here is that basically the AC cables in this submarine application and underground onshore application work consistently and reliably. And much of that confidence comes from the industry watching this same technology being used on increasingly large wind farms in Europe over a period of the past 15 to 20 years, and to a lesser extent experience in the United States, although that has been primarily smaller, lower voltage applications. So this is really resting primarily on the track record of this type of cable in a very well-developed European offshore market.
Do my colleagues have any further questions about the AC technology selection? Anything further?
I have a follow-up question for Ms. Johnston. The environmental impacts associated with the converter stations, would those impacts primarily be like in the form of land use, or are converter stations especially noisy or especially tall and, you know, visually obstructive or anything? Does anything stand out in terms of the type of impacts associated with those facilities?
So Mr. Arruda may have more to add specific to the actual design of these converter stations. What I was referencing was mostly related to land use impacts. If we're talking on the onshore side of things, for example, are you citing it on a parcel which is forested? Just as an example, would you need to clear land? In the offshore environment, you would obviously have additional seabed disturbance and what comes with the construction, you know, temporary sediment disturbance, additional vessel traffic, things of that nature. Mr. Arruda, I'm not sure if you have any information to provide regarding, you know, the heights of these converter stations, if it's comparable to another substation, for example.
I don't have specifics on the actual HVDC stations. A lot of them are project specific, but they are very large structures. that do take up significantly more space, and they're a much more complicated system.
And significantly more space than like just a traditional step up substation.
Correct. Yeah.
Okay. All right. I'm all set. Thank you.
Yeah, just one more question. Are there offshore wind projects that the company is aware of globally in the United States that do use DC technology?
So that's a good question, and our reference book of operating projects, as we all know, is pretty slim. Essentially, Block Island and a small demonstration project down off of the Virginia coast. Now that said, there are quite a long list of projects in the permitting pipeline. Vineyard Wind 1 being at the front of the parade there. Most of them are using AC generator leads because they are relatively close to shore and can connect to interconnection points that are also relatively close to shore. But that said, certainly I can think of at least one project that plans to interconnect at such a distance that it will likely be HVDC. They haven't made any public filings that I'm aware of, so this is my deduction based on the length of ground they intend to cover. But the Equinor project that was successfully bid into the New York auction 6 months or so back from a lease area off the coast of Massachusetts is going to run all the way to Astoria in New York City. So that's a distance that I am assuming, but it's just an assumption on my part, that will be an HVDC setup. But as they make their filings, both at the federal and state level, presumably there'll be some detail for that. But that's the one example that I could think of at this point.
Thank you.
May I ask a follow-up question, please? I apologize if this is already in the record somewhere, but is there a difference in magnetic fields between an AC cable and a DC cable?
So I might suggest that if we could ask that question when we have our magnetic field panel. There are some differences, but I'd rather you hear about it directly from Dr. Wahlberg and Dr. Long rather than me try to paraphrase what they might say. So.
Okay, thank you.
I'd like to discuss the XLPE cables a bit. Vineyard Wind VW-1 at 3-5 is starting where I'm referencing my questions. The company selected XLPE cables for Vineyard Wind 1. Please compare XLPE cables to other technologies, such as pressure fluid filled or oil impregnated cables.
Sure. So I can start this, and Jack may want to add to it. So XLPE, or as it's otherwise known, solid dielectric cable, is clearly the current state of the art for these types of submarine and underground onshore cables, and it basically refers to the insulating material. And unfortunately, if we were in person, we might have brought with us a cross section, which makes it very easy to explain. But it's basically a dense plastic that is used as the insulating material. And in contrast, the other two cable technologies are things that were used in decades past. They certainly worked, they served their function, but they are, for lack of a better description, somewhat messier and more complicated to work with. So a high pressure fluid filled cable is basically a cable in a pipe, and the pipe is filled with a dielectric fluid, which serves as the insulating medium instead of the sheath of dense plastic. And the oil impregnated cables uses a wrap of pretty much what it says, oil impregnated paper, essentially in many, many, many layers to serve as the insulating medium. So there are examples, for instance, of high pressure pipe type cable under the streets of Boston. In many cases, they were installed 40 or 50 years ago. They've worked reliably. They provided good service. But as technology has moved on, the solid dielectric cable is clearly the better choice at this point.
Let's talk a little bit more about pressure fluid filled or oil impregnated cables being a little bit messier and, a technology from decades past. Just help me understand a little bit more the main disadvantages of those technologies for offshore installations. So I understand that there's probably a very technical answer, but if maybe we can try and make it understandable for me as well.
So once it's installed, if it all works as it should, they, like I said, they provide good service. But given that it is the high pressure fluid filled cabling is basically a pipe with a cable inside filled with dielectric fluid, if that were to be damaged or leak, is everybody getting that noise feedback? Okay, anyway, sorry. So if there were to be a leak, then you have dielectric fluid being introduced into the sediments or into the marine environment, and then have a repair to make, which is, because of the nature of the cable system, it is more difficult and, for lack of a better technical description, messier than a piece of solid dielectric cable.
Okay. And what about for the onshore installation? So we just talked about offshore, and why for onshore are those disadvantage? Is there a disadvantage?
So pretty much the same reasons. The solid dielectric is just it's easier to work with. There are no fluids of any kind involved. For those that were involved in the first Vineyard Wind case, you'll recall that was a particularly big issue for the town of Barnstable. They were insistent that the project which we intended to do anyway, but that it would use solid dielectric cable. They did not want fluid-filled cables in the streets of Barnstable.
Okay. I'm curious why the company selected XLPE cables for both the onshore and offshore portion of the project. I understand the advantages of XLPE cables. You've explained that, but I'm assuming that there could be other technologies besides XLPE cables. So why did the company select this technology for both the onshore and offshore portion?
Well, let me start that, and then Jack may want to expand on this. But XLPE, or is sort of code for solid dielectric, the heavy plastic insulation that I mentioned. So it works equally well in the submarine and the onshore realm, albeit for the submarine cable, you basically have three cables in a twisted bundle, whereas onshore, those are separated and have three individual cables making up a given circuit. I personally am not familiar with other types of solid insulating material. This is what I've, in my experience, I've seen as kind of the standard for this sort of cable. But Jack, I don't know if you can add anything to that.
The cross-link polyethylene cable is kind of
I'm sorry, sir. Could you start again, please? No, what?
the XLPE, which is cross-link polyethylene cable that Mr. Barton's been speaking to, is the state-of-the-art cable right now in the industry. It's the one that has the least amount of losses for this application, and is really, there's no reason to switch to a different cable. And it has, as he mentioned earlier, there's no environmental impacts from this particular type of cable like you would have in the other ones that Ms. Yellen spoke to.
Thank you. Is there any advantage from a cost perspective to using one type of cable for offshore construction and a different type of cable for the onshore portion?
We think we have selected the most cost competitive cable that has the reliability and the performance, the environmental performance that we're looking for. So I would say no, there's not.
Thank you. I asked a similar question a few moments ago, but are there other AC technology offshore wind projects that the company is aware of globally, locally, that use cable technologies other than XLPE?
Certainly of the current projects, things that have been built in Europe over the last several years, and things that are proposed in the United States and for which there is public domain information available. To my knowledge, the XLPE cable is pretty much the universal choice or standard. I'm not aware of somebody proposing other types of AC cable.
Thank you.
There's a cable called EPR that can be used for the lower voltages, but you wouldn't use it for the transmission part of our project. And even in the 66 kV portion where the wind turbines, the array section of the wind farm, that cable also wouldn't be desirable for various technology reasons, for losses and water infiltration and things like that. But that's the only other one that I've heard mentioned, but it would be strictly for the lower voltages. And in this case, it just doesn't fit with our project.
Mr. Aruda, do you know what EPR stands for?
Yeah, that's ethylene. Give me a second here. I'm just trying to. Ethylene propylene rubber.
Okay, thank you.
Ms. Yellen, would this be an appropriate place to take our mid-morning break?
So, Ms. Sharkey, I have about 2 questions remaining. I think my next question is if we could sort of fit it in. Thank you.
Wait, Ms. Yellen, could I ask Mr. Barnes, just for the record, could you give some examples of dielectric fluids?
So dielectric fluid is, at least in current times, is essentially a highly refined mineral oil. So it's no different than the insulating fluid that's used in transformers and other heavy electrical equipment.
Thank you, Mr. Barnes. So if they were to leak in an offshore setting, that would be polluting. Is that correct?
It's certainly something you would not allow to go uncorrected.
Thank you. Ms. Yellen, sorry about that.
Perfectly fine. The Vineyard Wind 1 final decision on page 17 states XLPE cables have significantly lower dielectric losses than high pressure fluid filled or oil impregnated cables and have been proven to be more reliable and easier to install. My understanding of a dielectric loss is that it is essentially a loss of energy due to leakage current and that this loss increases with temperature. Is that correct? And it's sort of a correct assessment on dielectric loss?
So I don't have that decision in front of me, nor that particular section for context. So I'm a little reluctant to interpret what the siting board meant when that was written. So perhaps that might be a subject for a record request if we can dig that piece out and then offer whatever clarifying remarks we could make to your question on that.
Can the company define what a dielectric loss is?
Well, the reason I'm hesitating a little bit on this is I'm not sure if the writer was referring to a loss of dielectric fluid, which is one thing, or if they were talking about the electrical characteristics of the cable.
Let's set aside the reference to the final decision and let's focus on the electrical aspects of dielectric losses rather than the possibility of a fluid leak.
Yeah, is the company, if we set aside the reference to the final decision, is the company now able to help me understand what a dielectric loss is?
Jack, can you take a swat at that?
I mean, on the basis of it, it's the losses due to the inability to dissipate heat. So it's your thermal losses that increase. Dielectric losses are losses due to thermal heating. But as Mr. Bond said, we can take a rec request on this too if you want a more refined answer on this one too. I mean,
I don't think that's necessary right now. Is it, from what you're saying to me, it just seems like a dielectric loss is sort of a form of an electrical inefficiency. Is that correct?
that would be a good summation of it. Yeah.
So is dielectric loss the main inefficiency for the XLPE cables? If XLP, do the XLPE cables have dielectric loss?
All cables have a certain amount of dielectric loss, yes. But XLPE has lower dielectric losses than, say, some of the other technologies that you referred to.
So while it has lower dielectric loss, is that the only loss and inefficiency of those cables?
There are other losses in the cable system also.
Okay, can the company explain a bit more about those other losses?
Ms. Yellen, why don't we take our break now and we will return and revisit that in 15 minutes.
Sure.
Thank you.
Donna, can you hear us, or are you having trouble reconnecting?
Okay, thanks. I'm back, Dean.
Thanks.
If we can go back on the record. Ms. Yellen, would you like to resume your questions? You're on mute.
I believe I've actually concluded my questions for project alternatives and project approach, unless my colleagues have anything further to add. I have concluded that section, so I'm happy to move on to my questions on route selection.
Does anyone else have questions on the topics that Ms. Yellen has been asking today?
I may have one question as a follow-up on perhaps project alternatives. Not so much about cable technology, but more on market orientation, if that would be appropriate.
Thank you, Mr. Green.
Sure. So again, for the panel, my question is whether Vineyard Wind is familiar with the Clean Peak program that has been recently launched in the Commonwealth. And that could be anybody.
So I would say for myself, I'm aware of it. I'm not as familiar with the specifics of it as I probably should be, but.
Just for the sake of moving the questioning forward, I'll give a sort of very elementary description, which is it involves pairing renewable resources with energy storage technologies to provide, if you will, a firm or a firmer type of clean resource to the system. And may involve pairing, let's say, a wind farm with a battery storage facility to achieve that coupling. Does that sound about right, Mr. Barton?
Yes.
Okay. So with that premise, I'm wondering if Vineyard Wind has had any discussions or perhaps any internal business development activity or thoughts about participating in the Clean Peak program for either this project or perhaps other wind developments that it's perhaps bringing to the Energy Facilities Siting Board at some point in time.
So I would say that's probably not something that this panel can intelligently address. I can add a little bit of history. I know that there was a storage element of an earlier Massachusetts PPA procurement, which was not implemented by the state, but that was some time ago. You know, in this case, the underlying power purchase agreement is now almost 2 years in the rearview mirror, and the project is proceeding based on that. Is Vineyard Wind thinking about this for future projects? I'm really not in a position to say. So that might be a question that would be better asked when Mr. Rodstrom is back with us on another panel, because Chris is more involved in some of that forward-looking aspects of Vineyard Wind.
I appreciate that, and I will defer that question for his return. Thank you.
Sure.
I'd like to walk through the companies that selected.
Ms. Yellen, before we proceed, Mr. Eugenio, do you perhaps have any questions you'd like to ask on what we've been covering so far this morning?
I think I do have a few, or they're just focused on one area, and I think they do encompass generally what we've been discussing. So if I could, that would be great. My questions are for anyone on the panel. We had talked a little bit about the shared transmission issue, and I believe we asked about regarding the characteristics of what shared transmission was and limitations of such a cable with regard to Craigville Beach. Generally speaking, would a shared transmission cable or shared transmission concept ordinarily land at a larger common site like Braden Point, for instance, where there would be room for converter stations? Is the concept there with shared transmission that in streamlining the operation, would you be able to forego additional land costs like road work and so forth once you're on land? I know it's a general question, but trying to get at the concept and the goals here, if you would.
So that question.
Just a sec, would you mind, Mr. Eugenio, trying to break that question into a few parts? There are just several parts to that question, and I'm worried that the record will not be clear to have a single response to multiple questions.
Right. I believe prior testimony talked about the limitations of a shared transmission concept. Generally speaking, and we were speaking it with regards to Craigville Beach and Vineyard 2. Generally speaking, would a shared transmission cable or shared transmission concept ordinarily land at a larger land site, like Braden Point, for instance?
Certainly a shared transmission system would be interconnecting at the grid where there is sufficient capacity to accommodate what that shared transmission system is designed for. Whether or not the landfall site may be right at that interconnection point as it would happen to be for Braden Point.
I'm sorry, as it would happen to be what?
As it would happen to be for Brayton Point, just as an example, is specific to the geography of any particular shared transmission system or the interconnection point associated with that. If you're looking at Barnstable, it wouldn't make sense for a shared transmission system to come in to Craigville Public Beach, for example. simply because a project of the size we're proposing now is appropriate at that interconnection point, but not something that would be, 2 or 3 times larger at this stage. Mr. Barton, I'm not sure if you have anything to add. It looked like you were about to say something as well.
I was just going to add that I think this question is clearly in the realm of hypotheticals, and I don't know, Mr. Eugenio, if you intended to imply that there was a shared transmission system and an attendant project being proposed for Brayton Point, or if it was a there could be scenario. To my knowledge, there's been some discussion in the industry about Brayton Point being a landing site for a shared transmission project, but to my knowledge, there's no specific proposal for that on the table yet.
I'll concede that. My questioning was along the line of project alternatives, and I don't know if there's any concrete in that respect, but I'm just trying to get a little more insight onto the means and the concepts by which we're going to put these cables ashore. I guess if I could just go with my follow-up question that I've tried to break down. Generally speaking, if you're going with a shared transmission concept, would that mean there's less disruption, less landfall work to be done? For instance, in this case, going up through roadways. Is the idea of streamlining with shared transmission something that is intended to generate, I guess, less landside disruptions, if you will?
So again, I think that's in the realm of a hypothetical. To my knowledge, the people who are promoting and are interested in shared transmission are trying to address things starting with the availability of large interconnection locations, the distance of those interconnection locations from the active wind leases. And they're positing a situation where at some point you basically run out of conveniently located generator lead tie-ins, and you have to take that next step toward a planned transmission system. And as we talked about last week, that's, that day could very well come, but for a project such as Vineyard Wind 2 that has a very direct and relatively short interconnection approach that can be accomplished again with 2 cables, and then those 2 cables in a single duct bank going up to West Barnstable. That is a very solid solution in this case, and there's really no merit to imagining what a shared transmission system would look like instead, because we have a very good solution, and one that, in fact, if you look at Vineyard Wind 1 and 2 together, have many of the characteristics that are talked about for shared transmission, a common cable corridor, et cetera. But again, I think that's all in the realm of the hypothetical for this project.
And I might add that in the study process, as we touched on Friday, there are limitations as to the loss of a single source. So 1200 megawatts is still limitations imposed by the ISO on what you can have going into these individual locations. And now the ISO is also looking at going forward is other contingencies like loss of right-of-way. So and as Mr. Barton pointed out, our interconnect request was for West Barnstable. It was studied at West Barnstable, and it's a good fit for West Barnstable. But while we can point out some of the so-called low-hanging fruit of where we have some old conventional fossil units that have retired on the coast, they'll come with their own limitations as to what can physically be interconnected at those locations. And you don't know some of that until you go through the detailed ISO New England studies, because they can uncover things that maybe weren't studied in the earlier days when those plants were built. They didn't fall under the same criteria for a new interconnection. So I just wanted to point that out. And again, the loss of right-of-way is something that the ISO is starting to look at quite a bit also, because they don't want large amounts of power in a single right-of-way. So that's another criteria here, and why our queue position where it's located in West Bonsall is a nice fit for the system in our project.
You're on mute, Mr. Eugenio. Sorry.
I'm sorry. Just one quick follow-up. So AC cables can be run in parallel to one another. That's correct? The same line or the same trench, so to speak?
Well, in this case, what we're proposing for the submarine portion of this are two cables, as we've discussed, spaced roughly 50 meters apart. And that's primarily so that you can safely install them one at a time. But when they come on shore and you make the transition to the shore cables go in a single common duct bank as described in the filings. So there are basically it's an 8 conduit duct bank, 2 of which are spares, 6 of which are filled with the 2 3-conductor circuits.
Okay, thank you. That's all I have for now. I appreciate it.
Okay.
Ms. Cuthan, do you have any questions?
No, I do not. Thank you.
Thank you. And Mr. Gerson, do you have any redirect?
Not at this time. No.
In that case, Ms. Yellen, we can move on to the next topic.
Thank you. I'd like to walk through the company's route selection process and its various stages. I'd like to begin with some sort of general offshore and onshore route selection process questions and move towards asking pointed offshore and onshore questions. So can the company explain whether or not it followed the same route selection process as it did for Vineyard Wind 1?
Sure, I can start on that. Our route selection process for Vineyard Wind Connector 2 is indeed extremely similar to the route selection process followed for Vineyard Wind Connector 1. On the onshore side of things, the scoring system we set up, for example, the criteria we assessed are very closely related between the two projects. I believe, I don't have the criteria in front of me that we used for the first project, but I believe, for example, we did not have tree clearing factored in as an onshore routing criterion for the first project. We do for the second project because one of the routing alternatives does utilize a long stretch of existing utility right-of-way, for example, where tree clearing may be necessary. So we saw it as relevant for this second project where it was not so for the first project. Also similar between the two projects is the offshore side of things, although with some notable differences. When we first filed our analysis for Vineyard Wind Connector 1, we did have a couple of offshore corridors that were still being assessed. We called them at the time an eastern route and a western route. The eastern route accessed some landfall sites that were located further east than the landfall sites that were ultimately selected for the project. But at the time of filing, again, we did have a couple of alternative offshore pieces that we were looking at. But in general, the selection of the offshore routing was extremely similar. In this case, obviously, we had the first project to build upon, which was obviously a huge benefit for Vineyard Wind Connector 2. Not sure if any of my colleagues have anything to add.
I think, Holly, you covered that well. The only thing I would add to that is that with Vineyard Wind 1 ahead of us and decisions rendered there, we knew that the Barnstable switching station as an interconnection point was basically taken. So by plugging in the 800 megawatt output of Vineyard Wind 1 into Barnstable switch, that used the available capacity there. So that was no longer an option as an interconnection point for the second project.
Thank you. Did the company do an analysis of the preferred route all the way from the offshore wind farm to the interconnection point? Or were the onshore and offshore route selection processes kept separate? I'm referring to the analysis at 4-2, table 4-1.
Sure. So the table you refer to, table 4-1, and again, this is from exhibit VW-1, does assess the total distances involved from the area offshore where the power will actually be generated to the interconnection point onshore. The reason we did this was to assess the maximum route length to each of these interconnection points, and then eliminate options that were essentially of excessive length, beyond which, for example, the AC cable design would be appropriate. So this was seen as an initial screening tool. In terms of, so that's kind of the global sense of, did we assess the routes from offshore all the way to interconnection point onshore? To put a bit of a finer point on it, our scoring analysis that is presented in section 4 of the petition, again, exhibit VW-1, is focused on the onshore routes. So the scores reflect from the landfall site to the interconnection point. As I said just a moment ago, we obviously had the benefit in the offshore of all of the routing analysis that had been performed for Vineyard Wind Connector 1. And we did determine that no superior offshore route is available. As discussed specifically in section 4.6 of the analysis, that corridor was identified through a process that included consultations with the Massachusetts Ocean Team and consideration of a number of factors, such as the resources and guidance provided by the State Ocean Management Plan, geophysical surveys Vineyard Wind conducted starting in 2017, and considerations of constructability. The offshore corridor was also carefully reviewed, of course, during state.
I'm sorry, was also what reviewed?
Was also carefully reviewed during state, regional, and local permitting of the Vineyard Wind Connector 1, largely in 2018 and 2019, including as part of the Siting Board's review of that project, as well as reviews by the Massachusetts Environmental Policy Act Office, Department of Environmental Protection, Cape Cod Commission, and the Martha's Vineyard Commission. So with a landfall site and an offshore origin in very similar locations, it was logical to utilize the same offshore corridor, albeit widened a bit, to accommodate the Vineyard Wind Connector 2.
Thank you. Yeah, I do have, and I believe a couple of my colleagues have further questions on the widening of the corridor, but thank you for providing me with that information. How the offshore routing selection process and the onshore routing selection process are a bit different, are obviously different. How are they eventually integrated?
So if I could offer an opening thought to that, and then I'm sure Holly will want to add to it. But there's in the petition, page 4-1, there's a paragraph that I think is good to keep in mind that kind of captures the challenge of doing this kind of routing. And if I could take a moment to read it, it says, for a project of this complexity, there are interrelated aspects of the routing, each of which is important, that must work together to achieve the project purpose. The offshore route landfall site, onshore route, substation site, and interconnection location are all critical aspects of the overall routing, and each must be feasible from technical, environmental, legal, permitting, and municipal support perspectives. Therefore, none of the aspects of routing can have a fatal flaw, and the ultimate selection is a balancing of all the factors discussed in this analysis. So it's an important point to keep in mind. And unlike in sort of traditional transmission line siting, where it's basically a point-to-point exercise, this by nature is quite a bit more complex, because you've got to have a submarine route that works, a landfall that works, an onshore route that works, a substation location, and then an interconnection. And you've got to be able to piece all those together. Even though you may study individual aspects separately, at the end of the day, they have to knit together into something that works as a whole. So it is kind of a unique challenge to do one of these studies.
Thank you, Mr. Barton, and that's precisely where I would have started my response. I think I have just a couple of additional thoughts that may be helpful. So the objective of the routing analysis, of course, is to identify a feasible, cost-effective design capable of delivering approximately 800 megawatts to a suitable interconnection point. And it was clearly designed to ensure, or it was rather designed to ensure that a clearly superior route was not overlooked. Consideration was given to potential impacts on developed and natural environments, and Vineyard Wind considered a wide range of potential interconnection locations, landfall sites, and offshore routing options, ranging from the landfall sites in terms of the dovetailing of the offshore route with the onshore route. The landfall sites range from municipal beach parking lots to unimproved ways.
I'm sorry, I'm sorry, the landfall routes range from?
The landfall sites?
Yes.
Range from municipal beach parking lots to unimproved ways and other developed and undeveloped areas. Initially, our routing assessment identified approximately 50 possible landfall sites along the south coast of Cape Cod, as well as along the eastern coast of Buzzards Bay. These initial landfall sites were reviewed in the context of those cable length limitations that we briefly touched upon in Table 4-1. As well as potential interconnection points, which then focused the analysis. Once we did identify West Barnstable substation as preferred, it focused the analysis of landfall sites to the south coast of Barnstable. As Mr. Barton was describing, the process of identifying a preferred route is unique and complex, not least of which because the offshore and onshore segments together form that project route, but there are very different considerations applying to the evaluation of those routes. Hopefully that addressed your question, Ms. Yellen.
Thank you, it did. Thank you, Ms. Johnson, and thank you, Mr. Barton. Do my colleagues have any further questions on the general route selection process before I move forward with offshore export cable routing? Go ahead.
Yes. So I think in both Mr. Barton and Ms. Johnston's response, you allude to the sort of coordination of the offshore and the onshore routing as a critical piece. And I wanted to add another layer to that, which is with respect to the offshore routing, you also have federal jurisdiction and state jurisdiction, which is another complicating factor. Is that correct?
Certainly.
Now, we seem to have dodged the bullet on the Vineyard Wind 1 project of, let's say, having state jurisdictional regulators select one route and the federal agencies such as BOEM choosing a different route that would not complement the choice made by a state agency. But I'm just wondering in general, whether you have any advice to state regulators or federal regulators for that matter, in terms of coordinating the process to avoid a situation where the state and the federal siting entities make incompatible choices about the preferred route.
That's a great question, and I think the advice I would offer would be to continued to follow the direction that we took back in the early days of Vineyard Wind 1, which is basically to talk about this early and often as the whole concept is starting to take shape. So, before we filed the COP and before we filed an ENF and the siting board petition, we had a number of discussions with the agencies, in some cases separately, and in some cases with a large group of resource agencies all in the same room to talk through primarily the ocean or submarine route and what we had in mind for potential routes, how we were narrowing that down, what we had in mind for an initial slate of landfalls, and we tried to test that to make sure there were no fatal flaws in what we were looking at. And as Holly mentioned earlier, the original offshore export cable concept did have some variations in it. It had an east and a west alternative to get through Muskegon Channel. It had the western route that's kind of on the table now, but it also had an eastern leg that diverged at one point and took us to some other potential landfall areas. And as we worked our way through the project, those options proved not to be necessary and were eliminated. But I think at the root of it is a lot of ongoing discussion to make sure that you don't end up with a scenario where the two ends of the bridge don't meet in the middle.
Is there a particular coordination mechanism that you could recommend to the siting board in terms of a milestone in the BOEM process that would help avoid that disconnect on the bridge, as you put it, or perhaps in the reverse, some aspect of the siting process at the EFSB that BOEM should perhaps be plugged into?
Well, I think I would sort of build on my thought of communication early, often, and whether that's at the initiative of the project proponent or at the initiative of one or another of the key agencies with a big role in routing. I think there are examples where EFSB listening in on a BOEM discussion could be helpful, and vice versa. And I think if somebody has some major heartburn with the route being looked at, the earlier in the process that can be identified, obviously the better. You don't want to find out you've got that kind of disconnect after spending 2 years in the review process. So I realize that's not a very precise answer to your question, but I think that's the gist of what everybody should be striving to make happen.
And as I preface my question, it is a bit of a hypothetical type of situation. From a practical standpoint, would you see the risk in this case as being diminished from the Vineyard Wind 1 connector, being that you've already accomplished federal and state approvals and there's a certain expectation about how the process works at this point, both federally and at the state level?
Yeah, that's a good point. And I would say, from my perspective, I think that risk has been hugely diminished by the fact that there's now been 4 years of data collection, study, review, poking and prodding on the ocean corridor. And while there will be some debate ongoing as to exactly where the Vineyard two cables should go in that corridor. And there's certainly discussion to be had on cable installation techniques and so on. I think the basic question of, is this the right corridor for this second project, has pretty well been hammered out in the course of all that work that led up to this point.
Thank you.
I have a few questions about the offshore export cable routing. I know my colleagues also have follow-up questions and additional questions, and I will turn to them after my sets of questions. Please refer to Exhibit VW-1 at 4-41. Please explain that the company explains that it identified alternative corridor options other than what was ultimately selected in Vineyard Wind 1. I'd like to understand why the company didn't proceed with reviewing those alternative corridors.
Just to clarify, why we didn't proceed with those alternative corridors for Vineyard Wind Connector 1 or for this project?
For Vineyard Wind 2, for this project.
Sure. So Mr. Barton and I both touched on a couple of options that had initially been assessed for Vineyard Wind Connector 1, which are not being proposed for Vineyard Wind Connector 2. One of those was what I referred to as the eastern option, or the eastern route. For Vineyard Wind Connector 1, ultimately, of course, Covell's Beach was chosen as the landfall site. There had been some landfall sites further east of that, and there had been a spur of the offshore export cable corridor that had trended to the east. Obviously, for Vineyard Wind Connector 2, we are not assessing, or we're not proposing landfall sites further east. So there was no need to revisit that more easterly portion of the corridor. The second option, or the second variation, if you will, of the offshore export cable corridor, initially assessed for Vineyard Wind Connector 1, was in the Muskeget Channel area. We had a western option and an eastern option through the Muskeget Channel area. Ultimately, the eastern option was selected for the project. The same reasons that eastern option was selected for Vineyard Wind Connector 1 are valid for why we did not revisit the western option in any detail for Vineyard Wind Connector 2. Namely, that western option went through the main channel, which has much greater water depths and much stronger currents. So to facilitate cable installation, ultimately, the eastern option in the Muskeget Channel area was selected.
Thank you. So table 4-5 of exhibit VW-1 which begins on 4-23. It is a scoring analysis for the onshore export cables. I do not see a scoring analysis with a weighted route scoring framework for the offshore export cable routing analysis. Why does the company believe that this is more appropriate to not have the offshore export cable routing analysis scoring framework?
So this was the way we had set up the scoring for we had set up the routing analysis for Vineyard Wind Connector 1 as well. But for this project, the primary difference is we have all of the offshore routing work for Vineyard Wind Connector 1 to rely upon for Vineyard Wind Connector 2 as well. It is all still relevant for this project. And that process did demonstrate that no superior offshore route is available. I would provide essentially the same response I did just a few moments ago, where section 4.6 of this analysis does discuss that the offshore corridor was identified through a process that included consultations with the state ocean team and consideration of the resources and guidance in the Massachusetts Ocean Management Plan. It has also been surveyed extensively by Vineyard Wind starting back in 2017. And the corridor was very carefully reviewed by state, regional, and local permitting authorities. with a landfall site that is in close proximity to the landfall site for the first project, as well as an offshore origin that is in very close proximity to the first project, it became logical to utilize the same corridor for the Vineyard Wind Connector 2 as for the Vineyard Wind Connector 1. Hence negating the need for a scoring assessment.
Thank you. In general, I understand that there are many ways that offshore routing differs from onshore routing. Could you please elaborate on those key differences?
Sure. I'm just looking for a reference that may be helpful to have open in front of you. So just a couple of references to our analysis, which is exhibit VW-1. Page 4-47 identifies essentially in a bullet point list the principal considerations and constraints factored into the offshore routing analysis. Top of the line, not surprisingly, is the feasibility of cable installation. We're working in a dynamic offshore environment where there are water currents and water depths and various morphological features of the seafloor, which all need to be taken into account in terms of the feasibility of an offshore route. Related to that is the ability to bury the offshore cables to a target burial depth, which is essentially a depth sufficient to protect the cables both from natural forces such as water currents, as well as from events such as anchor drops. So you want to be able to sufficiently bury the offshore cables within the seabed sediments. A couple of criteria from the state were helpful as well. I mentioned the Massachusetts Ocean Management Plan earlier. That plan identifies what are called special, sensitive, or unique resource areas, which cable projects should avoid. These include areas of hard bottom, areas of complex bottom, which may be areas of sand waves, for example, principally for a corridor like this. We started, when we were working on identifying this corridor for Vineyard Wind Connector 1, we began with mapping from the Ocean Management Plan for hard bottom and complex bottom.
I'm sorry, we began with mapping from the Ocean Management Plan for what?
For hard bottom and complex bottom, for those special, sensitive, and unique resource areas I mentioned. The surveys Vineyard Wind has performed have also refined the mapping of those special, sensitive, and unique resource areas. But certainly we began with the mapping in the Ocean Management Plan. In general, we'd like to have a route that minimizes the actual route length. This is both for, certainly shorter routes are generally more cost effective, but also in general, shorter routes usually have lower environmental impacts as well, since at some level at least, a longer route will require further disruption of the seabed to successfully install along that additional length. The analysis of the offshore routing also included where we thought a potential landfall site may be. It included considerations of water depth. It also included considerations of the bend radius for offshore cabling. So we wanted to avoid sharp bends in an offshore route. A couple other natural characteristics that we assessed in the offshore environment. Wanted to avoid steep slopes or side slopes if possible. Crossing large seabed slopes, for example, we would not want to further make offshore cable installation challenging or problematic. And the final bullet point here is not particularly relevant for this project in the long run, but if we were to cross navigation corridors, we would want to do that in a perpendicular orientation. This was a consideration that was a little more important for Vineyard Wind Connector 1 because one of the initial routes did engage with a navigation corridor. That is not the case this time around. In the onshore, again, just looking for the best reference for you. In section 435, I'll have a page number for you in just a moment.
I'm sorry, section 4.3.5.
Yes, sorry. And that's on page 4-15 of the analysis. Give you a moment to find that page. Once you get there, you will again see a bullet point list, which identifies initial screening criteria for onshore routes. These included the use of public ways, public roadway layouts, other rights of way, perhaps utility rights of way, essentially previously disturbed corridors that may be utilized for onshore routing. Where we did assess roads, we considered the width of those roads to be able to accommodate the buried duct banks. Somewhat associated with that, we assessed subsurface utility density to make sure that those roadway widths could accommodate both those existing subsurface utilities as well as the proposed duct bank. We did look at potential traffic impacts, trying to avoid busy commercial centers, for example, and dense residential areas. And we also assessed sensitive receptors. Certainly, if we were near a hospital, for example, we wanted to make sure that any kind of construction impacts would not negatively affect access to certain sensitive receptors. And that was one of the scoring criteria as well.
Thank you. So is it correct to say that the company evaluated their offshore and onshore routing selection processes based on certain criteria laid out in the exhibit VW-1? And that criteria has been, I'm curious how the company developed this criteria.
Certainly the initial screening criteria we used for Vineyard Wind Connector 2 are consistent with the initial screening criteria used for Vineyard Wind Connector 1. In terms of how we developed those criteria, we tried to look at a logical assessment of what potential project impacts would be. For example, we're looking at the onshore construction piece. You know that if you're routing within roadways, you will have at least some unavoidable impacts to traffic, although those can be mitigated, of course, with traffic management plans. But you will have some unavoidable impacts if you are within roadways. You also know that if you were to be constructing in a dense residential area, you will be having some impacts to residences there and residents. So we try.
I'm sorry. You cut out there. You will be having some impacts to residences there, and
I was just modifying my statement. You will be having some impacts to residents who may live in that residential area. So, on the whole, I think our selection of the initial screening criteria tried to look at a logical view of what potential project impacts may be, and what project requirements in terms of construction may be, to come up with a list that was relevant to generating feasible routing options.
Thank you. Vineyard Wind 1 considered an eastern and western offshore export cable corridor. Is that correct?
Yes.
And in Vineyard Wind 1, the company ultimately went with the western corridor, correct?
Correct.
So I don't believe the application materials in this case present any information on the Eastern Corridor. I know you've been speaking about this in this panel. Why just the Western Corridor for this application for Vineyard Wind 2? Why just the Western Corridor?
The Western Corridor accesses the landfall sites that are proposed for Vineyard Wind Connector 2, while the Eastern Corridor accessed landfall sites located further east, even of the landfall site ultimately chosen for Vineyard Wind Connector 1. So we didn't feel that the eastern option was relevant to the Vineyard Wind Connector 2 routing.
Would there be a reliability benefit to installing the offshore cables for Vineyard Wind 2 in a different corridor from Vineyard Wind 1?
Certainly there is a reliability benefit to installing a cable in a separate trench or separate alignment from another cable. In my opinion, there's no significant reliability benefit to installing in an entirely separate corridor. In fact, I think there is some benefit to installing multiple cables within the same corridor because it becomes essentially an established utility corridor in terms of mariners' knowledge of the area. And, you know, I think we've discussed shared transmission a number of times where shared transmission proposes essentially major transmission corridors to get offshore generated power to shore. These two projects, by utilizing the same corridor, in many ways have the same characteristics of a shared transmission system because they utilize a single offshore corridor.
Thank you. And to follow up just right from there, are there, I understand the positives and the advantages that you're talking about to installing these cables within the same corridor. Are there any reliability concerns reliability concerns for locating the cables in the same corridor? Are there any concerns?
So to the extent that you are concerned about reliability and maintainability in the future, we basically have addressed that by setting a minimum separation distance between the two Vineyard Wind 2 cables, 50 meters or about 165 feet. And then we've also in the application said that we would maintain a minimum spacing of 100 meters or about 330 feet between the Vineyard Wind 1 cables and the Vineyard Wind 2 cables. So there's enough separation, one, to facilitate installation, and two, if there were to ever need to be a repair to one of the cables, you can get at it, pull it up, work on it, and put it back in place without disturbing the other cables.
Thank you. Has ISO New England expressed any concerns about locating these cables within the same corridor?
They have not.
Thank you.
Can the company explain a little bit more about why the separation distances that Mr. Barton explained, why you feel those are sufficient separation distances to provide a good measure of reliability?
So I think the distances are rooted basically in an assessment of how much separation you need to safely execute a future repair should it be needed. So this is something that stems from industry experience, discussions with the cable installers, information from other wind farms. And there is in the record, I know we've provided, I believe, at least one information request that talks a little more in detail about about cable separation, but I don't have the number committed to memory. But it essentially.
Sorry, Mr. Martin. I was just about to jump in with that if it would be helpful.
Sure.
So our response to EFSB RS 23, I believe, is on point here. And as Mr. Barton was describing, there is no real one-size-fits-all solution, or rule of thumb is the term that's used in the U.S. Bureau of Safety and Environmental Enforcement's offshore wind submarine cable spacing guidance.
I'm sorry, offshore wind, what? Cable
Offshore
spacing?
Wind submarine cable spacing guidance. Sorry, the title of that guidance is a mouthful. So there's no real rule of thumb for offshore cable spacing, but Vineyard Wind's offshore engineers have assessed that a minimum spacing distance of 50 meters is sufficient. And that engineering guidance may still be modified, but that's the current thinking on spacing. And that is on page 2 of that same response, where the engineers are essentially describing a typical separation distance of 50 meters or 165 feet.
Thank you, Ms. Johnson. That's helpful. Sometimes in my simplistic view of thinking about like electrical contingencies, I try and imagine like whether a single event could damage multiple cables. And I'm just wondering if the witnesses have any comment on whether, a single anchor drop or a single anchor drag could conceivably, damage multiple cables in the corridor, or if that's, sort of not a realistic scenario to be thinking about.
So at least in my experience and in conversations with the project engineers, we don't foresee any event that at the kind of cable spacing we're talking about, it's likely to have multiple cables affected. I will say, as a general rule, we also have some geographic separation of infrastructure in mind when we are designing these projects. In fact, that's one of the principal reasons Koval's Beach is a variant landfall site for this project and not the proposed landfall site. We do see multiple benefits to separating the infrastructure at the landfall site locations.
And also, if I could add, underlying all of this is the assumption or presumption that you can achieve a good cable burial depth. And if you can't achieve that depth, that you properly armor the cable or protect the cable such that incidental fishing activity, anchors being dropped from fishing vessels and the like, cannot damage the cable, no matter what the separation distance is. So that's sort of a starting point for all of this.
Yeah, I just had a follow-up question on anchors. I sort of imagine just an anchor kind of just like sitting, superficially on the seafloor, but do larger ship anchors sort of like, I don't know, like nest themselves into the sediment, or kind of like, really settle in farther to the extent that it could be a risk to the cable? Or I guess, is your cable burial depth kind of selected based on, the threats that anchors could present to the line?
In a word, yes, the target burial depth is related to avoiding impacts from things like anchor strikes. And I'm just getting back to the reference I had given you earlier, page 4-47, as that initial list of offshore routing considerations. The second bullet point in that list is a burial risk assessment. And Vineyard Wind has performed a burial risk assessment to essentially ensure that the target burial depth is sufficient. I might suggest that more detail
I'm sorry, I might suggest what?
that related to that topic.
I'm sorry, you froze for a minute.
Am I back?
Yes.
You're back.
Okay.
I might suggest.
I might suggest that more detailed questions on that same topic be held to the marine construction panel, because my colleague, Ms. Hartnett, is much more familiar with the cable risk assessment, which has kind of been performed on the federal side of the project.
Oh, thank you for flagging that, Ms. Johnston. That's helpful. Carry on, Ms. Yellen.
Mr. Wong, I believe you might have a few questions related to this topic.
I do. And Ms. Sharkey, I have a couple of follow-up on what's been talked about. And then I have one standalone question that we could do after lunch if we get close to that, if that's okay.
Thank you, Mr. Wong.
So since we're on the topic about the separation distances, I wanted to get to that really quickly. Could anyone on the panel, for context, just give a general width that an onshore cable corridor might have, just so I can sort of visualize the difference between the distances for an offshore and an onshore? Because I think for a single contingency event to affect, it sounds like for an offshore corridor, it's not that likely, but do you see where I'm going with the question?
Yeah, so I think I think of the two somewhat differently, because the onshore cable, while you're running two 275 kV circuits in close or tight proximity in the same duct bank, the duct bank is made up of, as I think we touched on earlier, 8 sleeves, 6 of which are filled, 2 of which are spares, but those are encased in concrete and then buried beneath the road surface with a minimum cover depth of 3 feet. So those cables have a degree of physical protection that you don't have necessarily for the offshore elements. So we are comfortable and confident that we have a reliable solution for the land link by putting them in as I said, a concrete encased duct bank. So the physical width of that, if you're using a 2 deep by 4 wide duct bank, is 5 to 6 feet. So relatively tight spacing.
Thanks,
and there
Mr.
are,
yeah.
I was just going to say there are illustrations of that in the record. So,
sorry for not being clear. I was more asking in general if you knew the difference between an onshore right-of-way versus an offshore corridor, not necessarily in ground, not necessarily tied to Vineyard Wind 2, but maybe for example, above ground right-of-ways versus this offshore corridor.
Okay, I got it. So on the Cape, there are, as you know, a number of rights of way that are used for existing overhead lines, 115 kV, 345 kV. And from my general knowledge, those range in width from on the order of 150 feet up to maybe 200, 250, 275 feet typically. And for the wider rights of way, it's not unusual to see as many as three overhead circuits and sometimes a distribution circuit or 2 in a right of way of that width.
Thank you. These questions are going to be a little scattered because they're based off of a lot of running commentary from before. But Mr. Hazel, do you have a question? Okay, so Ms. Johnston, you had So we talked extensively about the western and eastern corridor for Vineyard Wind 1. And as Ms. Yellen mentioned, there wasn't that much discussion in this record in the filing besides the fact that company stated that it's settled on the western corridor. And this question is related to the need to find that the project approach is preferable to an alternative. Is in this Vineyard Wind 2 case, is the Eastern Corridor something that we should be discussing as an alternative, or is it not, and we should only be talking about the variance when it comes onshore?
So I would say the eastern option, we'll call it, of the offshore export cable corridor presented for Vineyard Wind Connector 1 is not a viable alternative for Vineyard Wind Connector 2, mainly because it does not access the proposed landfall sites for Vineyard Wind Connector 2.
Thank you.
Just, if I could I add a quick point just in the interest of clarity of the record? So when we talk about the eastern option, basically probably 90% of the cable corridor starting offshore and coming north was common between the eastern and western, and the eastern option was a leg that basically took off once you got past Muskeget Channel, well past Muskeget Channel, and that headed toward a couple of eastern landfalls. So it wasn't an entirely separate and distinct route. It was a variation of a largely common route.
Thank you both. So this has been repeated a few times, but just to ask it in a different way to see if I'm understanding it right. If the company were to use its other lease area for Vineyard for a wind farm, this corridor wouldn't be the optimum necessarily, because that's in a separate area.
I'm sorry, this corridor wouldn't be what?
Wouldn't be the optimum corridor necessarily, would it? Because as Ms. Johnson has stated, it's because it's from a similar point offshore to a similar point onshore. Is that the right flavor of that?
And I'm assuming the lease area you are referring to is lease area 522?
Yeah, yes.
It's on the eastern side. For those who may not be familiar, that lease area is on the eastern side of the block of lease areas offshore. So I would say that theoretically, a project from lease area 522 could utilize the same offshore corridor, but it would add significant length to any route from that lease area, and it would also likely involve cable crossings of cables that we anticipate may be in place from other lease areas at some future point in time. Again, that's hypothetical, but talking about potential future routing.
Thank you.
That would
thank you for that. And we also talked a little bit about the Massachusetts Ocean Management Plan and how that's discussed a little bit in the analysis with regard to how the routes were selected. And I believe that discussion also talked about the OMP having some suggested routes. Could we talk about why those routes were rejected? Were they just generally deficient, or were there particular reasons? Like, would they have not worked for any other project, or were they specifically not right for this project?
So they were specifically not right for this project. There are a couple of reasons. The routes did not, preliminary corridors is what the Ocean Management Plan called them. First of all, the preliminary corridors did not cross through the kind of donut hole of federal waters within Nantucket Sound, if you will. We have chosen to cut across those federal waters because it's an efficient route in terms of shortening route length. And aside from simply being in federal jurisdiction, there's no other reason not to cross through those waters. So that's one way we deviate from preliminary corridors.
I'm sorry, that's one way. I'm sorry, that's one way we deviate what?
Corridors?
Sorry, you froze again. Deviate what?
From those preliminary corridors.
Thank you.
Sure. I apologize for the video freezing. There are a couple other considerations and reasons why those preliminary corridors are not particularly helpful for this project. They do not make any landfall in Barnstable. So similar to Vineyard Connector 1, which will interconnect at the Barnstable switching station, we're obviously using the West Barnstable substation. Any interconnection in Barnstable would not have an efficient route if utilizing the preliminary corridors identified in the Ocean Management Plan. The third reason those preliminary corridors were not particularly helpful to us is they did not include an assessment of water depths when they identified those corridors. So in many cases, the corridors actually pass through areas where water is quite shallow and hence more difficult for cable installation.
Thank you. That was the last point was sort of why I was curious about whether, because the water is shallow, I can't imagine that other wind developers would be okay with the. Okay.
Yeah, that's certainly correct. That last point would be presumably universal across wind developers. Now, certain preliminary corridors located further to the west, for example, may be more useful if water depths would allow use of those corridors, but certainly in our assessment, they generally followed shallower waters, and hence were not as helpful for cable installation.
Thank you, Ms. Johnson. So we talked a lot about how the other option, like the Eastern Corridor option and now the OMP preliminary routes would not land in a right place for this project. Would you say that grid interconnection points and landfall sites are big? I guess we talked about this earlier about the integration of onshore and offshore questions. So would it be fair to say that the landfall site and interconnection points are could it be the main reason for selecting a particular route?
They are certainly critical pieces. I would say among the earliest considerations in our routing assessment was an interconnection point, because you initially have a whole universe of routing options and you need to narrow it somehow, and identifying the best interconnection point is an excellent way of narrowing your routing analysis. But as we did say before, all components of the routing assessment are obviously very important. The landfall site, the substation site is again a very critical location. Obviously that interconnection point, and then the routing that connects all of it. You can't have a fatal flaw in any portion of that routing analysis.
Thank you. One more follow-up. So we talked about the fact that the Eastern Corridor is not going to be considered an alternative, but I had noticed, at least for the landfall sites that were considered that were pared down from the list of 50 landfall sites that was also used for Vineyard Wind 1, that the list, is that right? Were the landfall sites the same? The big list, was that the same?
I apologize, I was on mute. They were certainly largely the same. There may have been one or two nuanced differences, but
Yeah.
most of the landfall sites were the same.
I was, because I'd noticed that the contenders that were considered for this analysis for Vineyard Wind 2 were different from the landfall sites considered for Vineyard Wind 1. And I understand that Vineyard Wind 1 also had two different offshore corridors to consider. I am wondering about the timing of the analysis for the Vineyard Wind 2 landfall site selection, because I know everything that was considered for considering the offshore corridor was done previously. Do you know if the landfall sites considered for this project were considered in that previous iteration, or was it specific to this filing?
So certainly some of the landfall sites put forth for this project were assessed for Vineyard Wind Connector 1 as well. Obviously, they were assessed for the first project in the context of the Barnstable switching station being the interconnection location for that first project. The West Barnstable substation, of course, is the interconnection point for Vineyard Wind Connector 2. I think possibly, if I'm understanding your question correctly, you may be wondering why we're not looking at those landfall sites that are located further east. That would have been accessed by the eastern.
I'm sorry, that are located further east. What?
That would have been accessed by that eastern corridor.
No, this information might not even be that relevant. I was more trying to get a sense of.
I'm sorry, Wayne, you froze.
Sorry, I was more trying to get a sense of how I can differentiate between the analysis done for Vineyard Wind 1 and Vineyard Wind 2. I don't know if that's necessarily. I understand that it's more of a fluid sort of thing where there's not like a hard cutoff between the analyses, but could you, if there is, could you speak to that?
Just trying to think of a way to differentiate for you the two routing assessments. Are obviously quite similar because they are two similar projects. I think one of the primary differences, if I may, between the routing assessments for the two projects is the routing assessment for Vineyard Wind Connector 2 assumes construction has already occurred for Vineyard Wind Connector 1, and hence that is a routing constraint. For example, we did not prioritize landfall sites located further east because we didn't want to have to cross the duct bank for Vineyard Wind Connector 1 in order to get to the interconnection point for the Vineyard Wind Connector 2 project.
Okay, thank you. Ms. Sharkey, I have one set of questions. Do you think we should try to plow through them, or? Okay.
Why don't we pick them up after lunch?
Okay, sounds good.
Okay, we'll be back at 2. Thank you.
Dean. Zach is trying to get in. He's in the
My apologies. There we go. And Mark too. There we go.
Thanks.
You bet.
So Holly, I see you've upgraded your background. Very nice.
No one's looking at my vacation picture on the wall behind me today. Going for the more monotone look.
I'm staying with my traditional office over the garage dormer look. So.
Okay, it looks like everybody's back. Mr. Wong, would you like to resume? Back on the record?
Yes. Thank you, Ms. Sharkey. So this question's already been answered in some part, but I just need a statement in the definitive about what I'm going to ask. So, Ms. Johnston, you had stated that the expansion of the offshore export corridor is required for Vineyard Wind 2. Is that correct?
Yes, that is correct.
Yep. And however, looking at a high-level drawing in the DEIR, specifically figure 2-2, it doesn't appear that the line veers into the newly surveyed areas. Could you explain that briefly? Thank you.
Sure, I'm just pulling that figure up on my screen. Yes, so figure 2-2 does show the expanded offshore export cable corridor. It also shows the preliminary cable alignments. Of course, there will be 2 preliminary cable alignments for the Vineyard Wind Connector 2. And you are correct, those alignments themselves are within the bounds of the original offshore export cable corridor. However, well, first of all, those cable alignments are preliminary, so they can move within the offshore export cable corridor based on refined engineering moving forward. But also to consider the entire offshore export cable corridor as expanded for the Vineyard Wind Connector 2 encompasses not only the 2 proposed cable alignments, but also the installation activities associated with burial of those 2 cables. So for example, the anchoring spread that will go laterally from the cable installation vessels, those actual anchoring locations must remain within the expanded corridor. So we wouldn't want a cable alignment, for example, to nestle right up to, say, the western margin of that expanded corridor, because you wouldn't be able to anchor any further west.
Okay, thank you for that. And this might be on the record, but could you state again whether the potential 3rd set of lines would be located within the expanded corridor, or would you expect a further expansion if a 3rd pair of lines were to be put in the same corridor, considering also the anchor spread and the construction requirements?
To my knowledge, that is not yet known at this point in time, whether a theoretical 3rd set of cables would be within the actual alignments, whether those would be within the original corridor or the expansion area.
Thank you. This is a slight tangent. With regard to an offshore corridor, what is its main, how is it different from an onshore corridor? I'm just imagining that for an onshore corridor, you have to clear it completely, but for an offshore, you don't necessarily have to do anything besides within where you're micrositing the cable. Is that correct?
Absolutely. And the Marine Construction Panel will certainly have more to say on this topic as well. But you are absolutely correct that although we are identifying a corridor for installation of these two cables, the vast majority of that corridor will remain unaffected by the project. In reality, you will have two narrow strips of seabed directly impacted by the trenching operation, and then you will have anchoring on either side of the cable.
I'm sorry, and then you will have what?
Anchoring, which will be in addition to the direct trenching impacts. And then you may, in certain instances, have cable protection, although obviously Vineyard Wind is trying to minimize and avoid the use of cable protection.
Thank you, Ms. Johnson. I'm all set with my questions for this section. Sharky, or?
So is Ms. Yellen also concluded with her questions for this section? You're on mute, Joanna.
I apologize. I have concluded my questions regarding the offshore cable routing. I still have questions related to route selection. So if I may continue.
Thank you.
On to landfall, a few landfall questions. Is it true that the company reviewed a universe of routing options shown in Table 4-1 of Exhibit VW-1 of the analysis from its offshore lease area to the ISO New England grid? Is that correct?
That is correct.
Can the company confirm that these routes were screened for excessive length and interconnect capability?
Yes, we did.
And after eliminating routes based on excessive length and interconnection capability, the company's end result was one potential interconnection point for the Vineyard Wind 2 project development in the town of Barnstable, the West Barnstable substation. Is that correct?
Also correct, yes.
The company seemingly limited its universe of routes to just Barnstable. Why just Barnstable?
So as you referenced, the initial universe of routes is essentially shown in Table 4-1. It was also illustrated on a figure in the analysis. That was figure 4-2 of the analysis. It's essentially a graphical representation of what is shown in the table. You'll notice some rows of Table 4-1 are highlighted in gray. Those are the options that were essentially eliminated based on route length. You will notice that although we identified a rough maximum length of approximately 71 miles, we didn't see that as a bright line. For example, Brayton Point at a total of 76 miles, we did not eliminate based on route length alone, and that option made it to, if you will, the next step of the routing analysis. But nonetheless, a number of the routing options shown in Table 4-1 were eliminated based on excessive route length alone. For the options that were not eliminated based solely on route length, we assessed whether the interconnection points associated with those options had capacity to accommodate the proposed project at approximately 800 megawatts. These are described in section 4.3.2 of the analysis, beginning on page 4-4. And they are also summarized in their comparison in Table 4-2 which is on page 4-7 of the analysis. That may be the easier place to look for this discussion. Again, table 4-2. That table illustrates that Barnstable indeed was the only interconnection point retained for the routing analysis. In the case of Falmouth, we found it really was not of acceptable length. We found that it did not have sufficient capacity to accommodate the project. It was of acceptable route length. The same could be said for Mashpee and Hatchville. Barnstable switching station was also the same. Obviously, Barnstable switching station will not have sufficient capacity because it is accommodating the Vineyard Wind Connector 1 interconnection. Pine Street, again, does not have sufficient capacity. And then Brayton Point, because of queue positions, does not have sufficient capacity and is also at 76 miles, significantly longer than the route length to Barnstable. So it's also eliminated based on that criterion.
So is it safe to say that Barnstable, the basic main reasons why Barnstable was selected is because it has acceptable route length and sufficient capacity?
Yes, I would say that is accurate.
Thank you. Regarding the company's route selection process for selecting the interconnect location, is it correct that the company first identified several potential substation locations and then narrowed this list down by eliminating the routes that exceeded 71 miles in total cable length, which left the company with 7 potential options?
Yes, I might just modify your statement with the clarification that although we do have 71 miles as an approximate maximum, we didn't necessarily draw that as a bright line. Like I was saying before, I used, for example, Brayton Point at 76 miles. It was not eliminated solely based on route length.
Is Brayton Point the only location that was eliminated that was over the exceeded 71 miles, but was not eliminated based solely on route length?
The Pine Street substation in New Bedford, which is shown in the 3rd row of table 4-1, is at 72 miles total length. So just above that 71 mile threshold as well.
Thank you. Please explain the process the company used to narrow the list down to these 7 potential interconnection points.
So if I understand your question correctly, it does tie back to that potential maximum route length, where we assessed the universe of options, again, as a first cut against the maximum route length of 71 miles. Anything that was significantly over that fell out of the analysis, and we proceeded with the options that were of reasonable length.
And what is the full interconnection capacity of the West Barnstable substation?
Mr. Barton or Mr. Agruda, do you have anything to add here? I know that we deemed it would have an acceptable capacity to accommodate the 800 megawatt Vineyard Wind Connector 2.
And go ahead, Jack.
No, that's good. During the feasibility phase, it was analyzed and it was found sufficient to accommodate the injection of 800 megawatts.
Thank you.
Can I ask a quick follow-up to Mr. Aruda's point? I'm curious how the feasibility analysis went, because it's my understanding that there are several pieces of additional equipment that need to be added to the West Barnstable substation to accommodate the interconnection. So it's not that the West Barnstable substation in its current state cannot accept the project. Is that correct?
That's correct. There were upgrades identified in the system impact study, which would not have come out of the feasibility study, that need to be implemented.
Can you explain a little bit of the difference between the feasibility study and the system impact study? It sounds like the feasibility study indicated that West Barnstable would be an acceptable location, and then maybe when you took a closer look at it, you found, you know, what specific upgrades would be necessary.
Correct. It's still an acceptable interconnection point. It's just there were additional upgrades identified when you got through the full system impact study analysis.
Gotcha. So in the feasibility phase of looking at interconnection points, did the company consider the possibility of making upgrades to other substations? Or it seems a little like you would almost be looking at substations on an unequal basis. If one substation you're saying, well, this works with additions, but this other substation does not work in its present state.
Yes, so you got to look at the system as a whole, and understanding that you may be subject to additional upgrades that come out of a system impact study, because it's a lot more detailed study, and it looks at various contingencies that you don't necessarily look at during a feasibility study. And West Barnstable had the potential to accept those upgrades in a reasonable manner, because there was already 345 and 115 in that Barnstable substation area. And there were ongoing reliability projects that were targeted for that area that would be a good synergy with the Vineyard Wind project and help advance all the interconnections on Cape Cod, you know, in the future. So while you can't always identify everything in a feasibility study, there was nothing in there that gave us pause not to pursue this QP 700 for this particular interconnection.
Okay, thank you for the additional detail. I appreciate it.
So, Ms. Johnston, you, and this question is for the entire panel, but Ms. Johnston, you helped me and you described how excessive length played into and impacted the overall feasibility of the route. Does cost come in as a factor for selecting an interconnection point?
Cost is certainly involved in this step of the routing analysis associated with route length. On par, a longer route will obviously also cost more. Specific to the interconnection point and cost related to the interconnection, I'm not sure if Mr. Arruda has anything to add there, but certainly unless there are other important factors which distinguish two routes, one route that is significantly longer than another can certainly be expected to be significantly more costly than another.
And I can add that we absolutely consider cost when we're looking at a point of interconnect, but we also look at the potential, can the upgrades that you may have thought that you needed to implement based on some initial screening, can they truly be implemented? So there's two sides. There's the cost of part of it, and then if you perform those upgrades, are you still injecting at a robust part on the system or system of need, area of need, and those are the different things we do look at as a whole. And that's how we got, you know, West Barnstable. As I said, West Barnstable, and I don't want to speak for the transmission owner, but that's kind of the main hub for Cape Cod right there, that West Barnstable substation. That's where main transmission comes down. And then from there, it kind of, you know, spreads out across the Cape from there over to Barnstable. There are lines coming from the Bourne area down to Falmouth, but it's all intermingled. But the West Barnstable substation is one of the key substations for Cape Cod.
Just if I might, to add a point to that, in some of the first round discovery requests, and specifically EFSB RS 2, 3, 4, 5, we were asked to elaborate on basically what would be required for interconnections at some of the smaller outlying substations like Falmouth, Mashpee, et cetera. And in each of those cases, not only would there be a lot of work at the substation itself, but because they're all served by a single 115 kV line, you would have to build at a minimum a second 115 kV line back to a central location like West Barnstable or Bourne in order to make those work. So those there's a series of 4 information requests that kind of provide that next layer of detail on that whole examination.
Thank you. The petition indicates that, and by the petition, I'm referring to Exhibit VW-1 at 4-3. So the petition indicates that at a certain length, an offshore transmission line would require reactive compensation. Can the company explain a bit about the engineering challenges related to reactive compensation?
I can start that, and Mr. Barton and Johnson can chime in here. We're talking about the reactive compensation. This goes back to our earlier discussion on AC versus DC and things of that nature. The AC cables, when you get to a certain length, in order to maintain an acceptable voltage profile throughout all of your generation range, you may have to add some midpoint compensation to that cable. And the midpoint compensation, or a compensation doesn't have to be exactly midpoint, but compensation along the offshore cable route, then it involves the installation of another platform or some point along that offshore route where you can build this reactor station. So it adds a whole nother layer of permitting another structure, building another structure, the cost incurred with it, and having that other structure offshore.
So how did those challenges factor into screening out the interconnection points?
So certainly the possible need for midpoint reactive compensation was the driving factor behind the step in our routing analysis of eliminating routes of excessive length. We wanted to avoid the need for that additional offshore infrastructure, both from a cost perspective and an environmental impact perspective and a risk perspective in terms of permitting and acquiring the rights to the seabed where such a structure may need to be installed.
Thank you. Regarding the company's process for selecting the landfall site, is it correct that the company first identified several different landfall sites, and after eliminating the options that did not have adequate workspace, the company was left with 12 promising options?
So as shown or as described on page 4-8 of the analysis, this is exhibit VW-1, the paragraph in the middle of that page explains how we narrowed landfall site options from the 50 or so initial screening options down to 12 promising sites. 19 of the landfall sites were disqualified because they lacked sufficient workspace, but 19 others were eliminated based on challenges with egress or sensitive environmental resources.
Thank you. Can the company please explain whether the host community support, whether host community support was factored at all into the landfall site selection process?
I could start on this. I would say that we do take that into consideration. Obviously, having a willing host community and someone that you've worked with already is definitely an advantage than, going into a new location and not knowing what the feedback will be. And since a second project was contemplated during the host community agreement for Vineyard Wind 1, that was obviously something that we take into serious consideration during our evaluation.
And is the company aware of any landfall sites outside of Barnstable that would be superior to Craigville Beach on the basis of either environmental impacts or cost?
Certainly not. And in fact, in the process of identifying landfall sites, just to summarize again, we had the more than 50 kind of in the universe of landfall sites. We pared that down to the 12 that we just talked about. And then once the interconnection, once the proposed substation site was identified, that further narrowed the 12 to the 5 remaining landfall sites that are assessed in the analysis. It focused us on the south coast of Barnstable, but certainly our assessment of landfall sites went further afield than just the coast of Barnstable.
Thank you. I'd like to understand a bit more about how the landfall sites were assessed for an HDD operation. I'm mostly referring to 4-8 of Exhibit VW-1. One of the criteria used to identify potential landfall sites included ensuring that there was enough space to accommodate the HDD. What does enough space mean?
So we used approximately a half-acre area as an assumed workspace sufficient for HDD.
And this next question may be best formatted as a record request. But what are the minimum space requirements for an HDD operation in this case?
So Mr. Aruda, I don't know if you know the acreage of our HDD workspace at Craigville Public Beach off the top of your head. I do not, but in the assessment of landfall sites, we did consider a half-acre to be a pretty solid minimum assumption to allow for some flexibility in laying out the workspace for an HDD operation.
I agree. That's a very reasonable footprint needed because there's a fair amount of ancillary equipment that comes with the operation.
I'm sorry, there's a fair amount of what?
Ancillary equipment.
Thank you. No need for a record request. Thank you. Please refer to Table 2-6 on page 2-45 of the DEIR.
Forgive me, I'm sorry. Page 2-45 of what?
Of the DEIR.
That was Table 2-6?
Correct. The table indicates that 0.2 acres of the preferred route constitutes as a new impervious area. Can the company identify which aspect of the company's preferred onshore transmission route constitutes the 0.2 acres of new land alteration?
So footnote 3 of that table explains that the substation design will increase impervious area at that substation site by approximately 0.2 acres.
And that's, if I could add to that, that's basically coming from looking at the fact that part of the substation site is already in a developed state as a motel with associated parking and driveways. So there's some amount of impervious surface on the site already that will all be removed in order to build the substation. And while we will be adding some new impervious surface in buildings and containments. The net is just that 0.2 of an acre.
Thank you. And so when you say disregard, do my colleagues have any further questions about anything regarding the landfall or the interconnection point? Regarding the companies, and I understand that there are updates to the proposed substation. I'm going to still ask several questions regarding the substation site. So regarding the company's process for selecting the proposed substation site, now with there being updates, is it correct that the company identified using unique criteria for potential sites for the project's onshore substation?
I'm sorry, you actually got a little bit garbled on my end. Would you mind repeating your question?
Oh, I apologize. Regarding the company's process for selecting a proposed substation site, is it correct that the company identified using unique criteria for potential sites for the project's onshore substation?
Yes, that is correct.
Can the company explain how the groundwater protection overlay district will or will not impact the construction of the substation?
So the same, oh, sorry, Mr. Martin, go ahead.
No, I was just going to say there was a lot of groundwork on this subject laid during the course of the first project. This was an area of interest to the town of Barnstable. So we had a good deal of discussion. We agreed to basically a set of design steps that went well beyond industry standard practice to make sure that the fluid-filled equipment, the transformers, and a few other pieces were completely contained, not only for the full volume of dielectric fluid, but a margin of safety on top of that, and then a very rigorous treatment of precipitation as well. So by doing all that, we think we have eliminated any potential risk to groundwater, and that same philosophy has carried over to the design for this project.
And I assume it's also been carried over for the updated substation design.
Yes.
And what about the operation of the substation? We just discussed the construction of the substation and the groundwater protection overlay district's impacts. What about the operation of the proposed substation?
So those measures that I described, while they are built during the construction phase, they're really aimed at minimizing or eliminating any risk during the operation of the.
I'm sorry, during the operation of the what?
Of the facility.
Thank you. I have a question or two for the company regarding the MassDOT parcel. I understand that was also considered as a potential location for the substation. You may refer to EFSB RS-26. Is it correct that the MassDOT parcel has no abutters besides the motel?
The abutter on the northern side of the MassDOT parcel is currently the triangular Chamber of Commerce parcel that Vineyard Wind has an option to purchase, and that we've discussed in the context of the site layout revisions for the substation.
And is that parcel is presently undeveloped, correct?
That is correct, yeah.
Can the company discuss in a bit more detail why it didn't further pursue an acquisition of the MassDOT parcel?
Mr. Arruda may have more to add here. But the major risk with pursuing acquisition of this parcel is the disposition process that would be needed. And it had a very uncertain timeline. I believe, yeah, this is addressed in Part B of EFSB-RS-26. And it, I believe, is also addressed, yes, in section 4.3.4.4 of the analysis, exhibit VW-1. Described there, the process of acquiring property from a state agency is complex, and the timeline for the disposition process with Mass DOT was quite uncertain. I know that Mr. Rodstrom had some additional discussions with Mass DOT, so if there are more specific questions on the timeline itself, those questions may be appropriate to hold until Mr. Rodstrom is able to join the panel again.
Mr. Hayes.
Can you explain how the acquisition of the MassDOT parcel would be different from how the company's acquiring the Triangular Chamber of Commerce parcel?
So the triangular, the 1 acre triangular parcel was owned, was owned by the Cape Cod Chamber of Commerce. So we were able to have a direct, business to business discussion about whether they would be willing to sell that land, which they were. There was, without getting into all the details, there was an appraisal, there was a negotiation, a price settled on, and an agreement reached. And MassDOT's only involvement in that was that they had a right of first refusal dating back to when the Cape Cod Chamber first acquired the parcel some decades ago. But other than that, it was a straight business to business discussion. So that's very different than the larger Mass DOT parcel that we've been talking about, which was at least considered as a potential substation site. And as Holly mentioned, Chris probably can speak to this better, but the process, as I understand it, first involves Mass DOT consulting with other state and non-governmental organizations to see if somebody has an interest in the property, if it's decided that it's surplus. So another state agency could say, yes, I'd like to use this for some purpose, and that's the end of the process. If it clears that hurdle, then there is as I understand it, basically a public announcement made that the property would be made available for sale, and there's a process that follows. So it can't be earmarked for Vineyard Wind or any other buyer for that matter. So as a result of that two-step process, there's a lot of uncertainty in whether or not the project could ultimately acquire that parcel. And in contrast to that, we were able to have a direct discussion with the owners of the motel who were interested in selling the property, and that process went along quite smoothly.
Mr. Barton, is it your understanding that obtaining a release of DOT's right of first refusal on the Chamber of Commerce parcel is simpler and could be accomplished more quickly than the process you just described for potentially acquiring DOT's rights to the larger DOT parcel?
That is certainly my understanding, but it's an understanding a distance from the actual process.
Thank you. Regarding the onshore routing from the landfall site to the substation site, the end result of that evaluation process is that the company identified 2 candidate routes and a number of variations to these routes. Is that correct?
Yes, that is correct.
And these candidate routes and variations were evaluated using a weighted scoring approach, the results of which are presented in Table 4-5 on page 4-23 of Exhibit VW-1. Is that correct?
Sorry, what was the reference you just provided? Could you just repeat that?
Sure. Table 4-5 on page 4-3 of Exhibit VW-1.
So I think I heard you reference table 4-5. But
that's correct.
Those aren't the, just to clarify, those are the scoring criteria, but not the results of the analysis.
Were the same criteria applied to evaluating grid interconnection routes, or were these only applied to the portion of the onshore route between landfall and the substation?
These were applied to both the transmission routes, which connect the landfall site to the proposed substation, as well as the grid interconnection routes connecting the proposed substation to the interconnection point.
Thank you.
Can the company elaborate a bit on how it developed the criteria shown in this table?
Sure. So the initial screening criteria we used for onshore routing are listed on page 4-15 of the analysis, Exhibit VW-1. We had touched on these slightly earlier in this discussion as well. But the scoring criteria, most of them directly stem from these initial screening considerations.
Okay, thank you.
Oh, I'm sorry.
Continue. Good, continue.
So some of them are not directly reflected in the scoring criteria. For example, sufficient road width. However, use of existing roadway layouts was a priority in order to try to minimize impacts during installation. So when we were considering the use of roadway layouts, we were of course considering roadway width. However, some of the initial screening criteria are directly reflected in the scoring criteria in table 4-5. Again, just using an example, the avoidance of dense residential areas was one of the initial considerations. And one of the developed environment criteria for scoring is a count of residential units along each of the potential onshore routes.
Ms. Johnson, I noticed that I think in the initial screening criteria, subsurface utility density is listed. And then in the actual criteria, that subsurface utility density is not included. But then in the final description of cost factors, utility density is back in the mix. So it seems like it was an important consideration, but for some reason it was omitted from being a scoring criteria. Can you explain a little bit about that?
So subsurface utility density is of course a concern for constructability. Road width is also a concern for constructability. Therefore, we wanted to factor those in initial screening because we wanted to make sure that we were identifying routes that could actually be constructed, that were feasible from a construction standpoint. Constructability itself is not one of the scoring criteria we identified, mainly because constructability is reflected in the cost analysis. So similar to how we laid this out for Vineyard Wind Connector 1, we saw constructability as addressed as a piece of the cost assessment rather than as a separate scoring criterion.
And so your constructability and utility density, are those like one and the same from the company's perspective?
Yes, I would say subsurface utility density is a factor in constructability. And if it's helpful, we do have a sentence to this effect in the record at the bottom of page 4-26 of the analysis. Let me just read you, it's one sentence. It said the company captured considerations of constructability, for example, existing utility density or sharp bends, in its evaluation of costs for the various routing alternatives.
Thank you. I understand. I'm all set, Ms. Yellen.
Thank you. Can the company describe how it went about assigning the various weights to each criteria?
Sure, and it would be helpful to have table 4-6 in front of you. That is on, it begins on page 4-25 of the analysis, and it also continues on to page 4-26. This table explains the rationale behind the weights assigned to each of the scoring criteria. For residential units, the highest weighting of 3 was chosen due to the potential for disruption during construction, and realizing that residents who live in the area are particularly sensitive to those construction impacts. Sensitive receptors, that was assigned a weight of 2, the middle weighting, in acknowledgement of their susceptibility to temporary destruction from construction activities, mainly access to a site or construction noise, for example, and the need to maintain that access throughout construction.
I see that table. I think one thing we're particularly interested in is, I mean, you can argue the pros and cons of each of these criteria, but did the company work with the town of Barnstable or any other stakeholders in sort of assigning the respective weights to each criteria?
We did not specifically have conversations with the town of Barnstable about the weighting criteria per se. However, we know that the town of Barnstable is quite interested in minimizing traffic impacts. So if you look at that line item, we assigned it the highest weighting of 3, for example. We know that residents are also quite sensitive to those traffic impacts as well. And being the Cape with some traffic challenges in general, we felt that the highest weighting of 3 was quite relevant there.
So it sounds more like you considered the general input of the town or various stakeholders, but didn't necessarily have specific conversations about the route selection, weighted scoring process.
That's correct.
Okay, thank you.
Can the company explain the differences between, I'm curious, and I don't know the definitions perfectly. So the differences between archaeological sites and historic resources.
So an archaeological site is considered a historic resource, but historic resources also encompass, for example, an historic district or an historic building, for example.
So is it correct to say that historic resources are a type of criteria that is defined by the number of historic sites?
Yes, that would be correct.
So the archaeological resources ratio is higher for candidate route 1 than it is for candidate route 2. Can you explain why? I'm referring to table 4-7. It's on page 4-34 of exhibit VW-1.
Yes, and you are specifically referencing the archaeological resources row of table 4-7?
Correct.
So in this particular instance, if you look at the definition of the actual scoring criterion for archaeological resources, this was limited to just the off-road pieces of the routing. So just the utility right-of-way segments of routing. And that's essentially because when you're within a roadway, you're already within an area that's been disturbed as a result of construction of that roadway. So the archaeological resources scoring criterion was actually the extent of, it's actually the length of a given route traveling through areas designated as having either moderate or high archaeological sensitivity solely along the utility right-of-way segments. So candidate route 1 follows a right-of-way into the substation site, follows a short segment of right-of-way, 0.2 miles. Candidate route 2 does not follow any utility right-of-way. So that's why you see a score of 0 for candidate route 2 for archaeological resources.
I see. Thank you. And potential to encounter subsurface contamination rate, the ratio is higher for candidate route 1 than it is for candidate route 2. That's the potential to encounter subsurface contamination. Can the company explain that one a bit?
Yes, so this particular scoring criteria, which is on page 2 of table 4-5, or page 4-24 of the analysis, is derived from the number of Bureau of Waste Site cleanup sites identified on or within 300 feet of each candidate route. And there were 2 such sites for candidate route 1, but 0 such sites for candidate route 2. And the other place to see these numbers, if I could just give you another reference which may be helpful. Is attachment E of the analysis, which is essentially, it is a table that shows you raw, ratio, and weighted scores for each of the routing options and each of the scoring criteria. And if you look under the potential to encounter subsurface contamination row, you'll see a raw score of 2 for candidate route 1 and a raw score of 0 for candidate route 2.
Thank you. My next question is in reference to EFSB RS-21.
That 2-1?
EFSB-RS-21.
21.
Yeah.
21.
If the company is stating that the weighted scores of 12.3, 11.8, and 11.4 for the preferred routes variance, 1, 2, and the notice
I'm sorry, a word dropped out.
Okay.
If the company is stating that the weighted scores are 12.3, 11.8, and 11.4 for the preferred route.
For the preferred routes variance, 1, 2, and the noticed alternative are all quite similar, is it safe to say that the company's main reason for selecting the preferred route variance is because the noticed alternative is longer?
Yes, that would be probably the most significant reason.
And what makes up some of the other reasons?
So one of the other reasons is the noticed alternative contains a couple of sharp bends that the preferred route does not. Preferred route variant 1 contains those same sharp bends. If you're looking at figure 1-2 of the analysis, you can see this. I'm also just bringing up another reference which may be helpful. The text below the text below table 4-9 on pages 4-38 and 4-39 is also useful in comparing the preferred route and the noticed alternative. Oh, geez, I'm sorry. That reference is incorrect. One moment. That was for the grid interconnection routes, not for the transmission routes. The proper reference is to the text on page 4-35, which compares the preferred route and the noticed alternative route in terms of the transmission routes that connect the landfall site to the proposed substation site. And there are a few reasons why the preferred route was found superior, even though the scores are similar. The preferred route does pass fewer residential units. This is 316 versus 362 along the noticed alternative route. It passes fewer sensitive receptors, 4 versus 6, as well as historic resources, 33 versus 38. As you referenced, it's also significantly shorter. It's more than 2 miles shorter to take the preferred route versus the noticed alternative route. So those are all focused on the development area criterion. In terms of the natural environment criteria, the preferred route also passes fewer wetland resource areas. Although the text does note that because we're in paved roadway layouts, really neither route will have any permanent wetlands impacts. But in terms of being in a buffer zone, for example, we do technically pass through fewer resource areas along the preferred route.
Thank you. I believe that concludes my questions on this section. I'd like to turn to my colleagues and ask if they have any remaining questions on route selection at this time.
I have a follow-up question for Ms. Johnston. If you would refer to attachment E of volume 2 of the analysis, which are the detailed scoring spreadsheets.
Mm-hmm.
So one of the columns is the criteria potential for traffic congestion. And it looks like, you know, the company basically assigned even integers to each route or variant. But then to the right of the overall score are individual factors that seem to all play into the potential for traffic congestion. So I'd like you to explain how each of the factors, such as length, surface width, lanes, MassDOT classifications, how those were considered in reaching the final score of potential for traffic congestion.
So the score itself is really tied to one of those subcolumns, if you will. The scoring is tied to the Mass DOT class. And again, this is described further in table 4-5 of the analysis, where road segments were assigned a ranking of 1 to 3. So that's where those integers come to play that you referenced. The segments were assigned a ranking of 1 through 3 based on the Mass DOT class. So private ways were a 1, minor roads and major arterials were a 2, and limited access and multi-lane highways were a 3, indicating you would have the greatest impacts on those types of roadways. These additional columns next to potential for traffic congestion in the table that you referenced are essentially just providing some additional information that's good to know for planning purposes. Had we had Mass DOT traffic counts for every road segment, perhaps we would have scored based on traffic counts, but they were not available for every roadway segment, so we felt it was inappropriate to use those as a consistent measure for scoring this particular criterion. In terms of surface width. So that's the roadway width we've touched on a few times in this discussion, as well as bridges and sidewalk, for example. Those are really more relevant for planning purposes in the engineering of the route and figuring out what the options are along the route itself.
Got it. Thank you. And then I think earlier you testified that archaeological resources are a type of historic resource. But I think in the route scoring, you know, they're listed in separate columns. They're separate criteria from one another. So can you just confirm that there was no, you know, double counting of the same resources in both criteria?
Sure. So archaeological resources were actually considered in 2 of the scoring criteria. They were considered in the historic resources criterion, as well as in the archaeological resources criterion. But they were assessed in different ways. So, for example, if a route passed adjacent to an archaeological resource, it's still considered a historic resource. So even if we were in road, we counted that in the historic resources criterion. However, the archaeological resources criterion itself, as we discussed just a few moments ago, was only focused on portions of the onshore routing utilizing utility rights of way. So those were tied to areas of moderate or high sensitivity archaeological considerations.
So moderate or high sensitivity, is that more related to, say, the potential to have an unanticipated discovery versus known documented sites?
That's right. And that's why we counted it in 2 separate ways.
Got it. That makes sense. Thank you. I'm all set.
Mr. Wong, do you have any further questions? In that case, why don't we take our mid-afternoon break, come back at 3:15. Mr. Eugenio, if you have any questions you'd like to ask as follow-up, that'll give you a few minutes break to before you start in on those.
And Mr. Wong, is there a particular offshore segment that the company might need to switch a witness out over the break? If you could maybe give them a heads up for that.
Yeah, I'd like to start with air and hopefully get into noise as well. So I believe that's Mr. Jablanowski. And I don't know if there's more witnesses that have to be sworn in.
So air would certainly be Mr. Jablanowski. Noise would be Ms. Hartnett. And we can have both of them available.
Perfect, thank you.
So we have a 15-minute break. I'll give them a 15-minute warning. It is possible it may take them a little bit longer to check their email and get onto the Zoom.
And we will want to finish up route selection with Mr. Eugenio at that point too, before we add new witnesses and move to a new topic.
We won't necessarily be able to coordinate the timing perfectly. They may appear during Mr. Eugenio, but we can swear them in afterwards, and that gives them more than 15 minutes to get here. So thank you. Good point.
Okay, then we'll be back at 3:15.
We make it 3:20.
We can be back at 3:20.
When I try to start the video, it says that I can't because the host has stopped it. Ah.
It says the same thing.
Is everybody here that needs to be here? Oh, I can let in Maria Hartnett as a panelist, right?
She is.
That's right.
Okay.
Just a moment, please. Sorry. Okay, thank you.
Back on the record. Mr. Eugenio, did you have some follow-up questions on route selection?
Yes, I do. Thank you. Everyone ready? To anyone on the panel, you'd mentioned before that Vineyard Wind 1, some research from that project was used in determining some of the landfall sites. Was any work or analysis or any lessons learned from Cape Wind used in the analysis on landfall sites?
From Cape Wind, not specifically that I'm aware of.
I understand. No lessons learned or anything of that nature for that, I guess you could call it a failed venture. I'll take that as a no, unless anyone has anything else. Regarding our request for information, we're obviously interested in variant 1, the Cobalt Beach landfill site. My client is
Sorry, sir, I'm sorry. So you got blurred there. Regarding our request for information, we're obviously interested in
the project variant 1, Cobalt Beach. And in the event of unforeseen challenges, I understand that's the trigger to cause you to go from Craigsville to Cobalt Beach as a landing site. In the answer, you identified things that could make this a reality: unexpected regulatory actions precluding the use of the site, challenges resulting from geotechnical evaluations that increase costs or environmental impacts that could lead to this variant 1 becoming the preferable site. Can you identify any of the regulatory actions which you are referring to here, be they land use, be they from D.P.U or otherwise?
Would you mind, Mr. Eugenio, pointing us to the response that you're referring to?
This is in our requests for information. I believe it was number, let me see. I'll just pull them out here in a sec.
Is it AK20, Mr. Eugenio?
Mr. Eugenio, you're muted.
In AK20, I could just read it to you again if you bear with me. The answer was, generally speaking, unexpected regulatory actions precluding the use of a landfall site or unexpected challenges resulting from geotechnical evaluations at increased costs or environmental impacts that could lead to an alternative landfall becoming preferable. So I guess my first question is what are the unexpected regulatory actions that you're anticipating could shift the project to variant 1?
So I guess to start, we're not anticipating that. We simply raised it as a hypothetical here. So we are, a year into the regulatory review at the federal and state level of the project at this point. And we are further along in the state process than we are on the federal process. But with that said, we have comments back on our draft EIR. We got comments from all the state resource agencies, and to my reading, there was nothing in there that had any of the state agencies objecting to or second guessing our choice of Craigville Beach as the primary landfall. We're obviously in front of the siting board today, and we have the benefit of some 300 information requests behind us. And my reading of that is that we're being asked a lot of fair and reasonable and objective questions, but I don't see anything in those that would tell me that the siting board has a strong objection to Craigville Beach or any objection to Craigville Beach. But obviously that's not my conclusion to draw. The siting board will reach their own conclusions, but we're still in process in the evaluations. So it's possible that one or another of the agencies could, for reasons that we don't foresee today, say that we'd prefer that you go to Covell's Beach. We don't see that. We don't see that in the tea leaves right now, but we also can't eliminate it as a possibility. And that's why we answered this question as we did.
Thank you. Similarly, on the line of geotechnical problems, I would guess that there's been no geotechnical problems obviously unearthed yet. What are the types of problems in this nature that you could see happening, or if you can't foresee anything here, experience you have in other projects with a geotechnical problem standing in the way of a primary alternative?
Take a first pass at that. From a geotechnical standpoint, not aware of any geotechnical issues that have come forth to this point that would prevent us not being able to do a horizontal directional drill from Craigville Beach. But some of the things that you're asking that could would be as if they, ran into a boulder field during the geotechnical.
I'm sorry. Would be if they what?
Encountered a boulder field or some type of rock formation that wasn't anticipated. That would make the geotechnical more, or the HDD more challenging to do at that site. And depending on how large that is, you could reach the point of being prohibitive, but we've got no indication of anything like that right now. And it's everything that I know at this point, and I'm not sure if the final geotech report has been issued, but I think it's a lot of very similar conditions that we found off of Covell Beach also. But that's an ongoing process right now.
Are there any just plain cost savings to going in through Covell's again, just because you're going through there with Vineyard Wind 1? just the ease of using the same corridor there.
Well,
No. Oh. Go ahead. I was just going to say, I am not aware of any cost savings that would come to the project with use of the variant Covell's Beach landfall site. To the contrary, it would involve about 0.4 of a mile of additional duct bank installed within Craigville Beach Road. So it would have some additional costs associated with it. Mr. Barton, I'm not sure if you were going to say anything different.
I was going to make the exact same point. So.
In terms of environmental impact, is there any special way? I understand, I listened to the testimony about the criteria in that entire process. Generally speaking, is there any environmental impact weight given to the use of public land for a landfall site versus private land for a landfall site?
No.
Or is it all considered, all things being equal there?
In terms of environmental impact, I can say no, there are no differences between public and private property, but I will point out, and again, this is back in that same table of scoring criteria we were discussing earlier. So this is table 4-5 of the analysis. Article 97 jurisdictional land.
I'm sorry, Article what?
97.
Article 97 jurisdictional land is one of these scoring criteria we used. This essentially, for each route scored, we counted the number of distinct areas subject to Article 97 jurisdiction crossed by each of those routes. Now, Article 97 land is generally conservation land,
right,
defined as properties primarily protected for conservation purposes. And this project will have no permanent impacts to the use of Article 97 land. But we did see this as more of a, the reason we scored it, even though we won't have permanent impacts to the use of such land, is we saw it as a timeline or permitting risk, since those additional approvals are necessary. But aside from this criterion, I can't think of any scoring criteria that are really tied to public versus private land.
And I would add, when you ask that question in the hypothetical, I would agree with what Holly said, but I'd also point out that if you were going to equate the two, you'd have to be talking about a piece of private land that, one, was available, two, was paved and had a substantial parking area where you could do the construction and then restore it. So we're not talking about just any piece of public land. We're talking about a very large beachfront parking lot, which the town is willing to let us use a part of, provided that we put it back to rights when we're done.
Okay. Are there any socioeconomic factors of the population along the cabling route which are considered either under the umbrella of environmental concerns or any other concerns? You know, i.e., sending the cable by the rich people, by the poor people. Is that a factor or not at all?
That really was not a factor in the routing analysis. The cable route is not proposed for an environmental justice community. Does it pose an air quality or solid waste hazard, for instance?
Okay, thanks. That's all I have on this topic. Thank you.
Thank you, Mr. Eugenio. Mr. Gerson, do you have any redirect?
If we were in the room, I'd ask for a moment to confer with my colleagues.
Of course.
I'll put my cards under the table. Adam, I don't have anything that I would ask for.
That's the correct answer. That is Vineyard Wind's answer.
Thank you. Then we'll take this opportunity to swear some additional witnesses in for Vineyard Wind. If the witnesses could be identified by the company, then I will swear them in.
Thank you, Presiding Officer. The witnesses will be AJ Jablanowski and Maria Hartnett. Both are present in the Zoom room.
Could you please raise your right hand and have it show within your Zoom window? Do you solemnly swear or affirm to tell the truth in this proceeding?
Do.
Thank you. Mr. Lang.
Yes. So, Mr. Jablanowski, we'll start with you for the direct examination. Could you please state your name and business address for the record?
AJ Jablanowski. I work at Epsilon Associates, 3 Mill and Main Place, Suite 250 in Maynard.
And in what capacity do you work for Epsilon Associates?
I am a principal of the company, focusing on air quality.
And on whose behalf are you testifying in this proceeding?
Vineyard Wind.
And was your resume submitted as attachment, I believe it was 8 or attachment 7 to the witness list that was submitted by Vineyard Wind in this proceeding?
It was submitted, yes.
And have there been any material changes since your resume was submitted?
No.
And did you participate in the preparation of Vineyard Wind's submissions in this proceeding, including the analysis to Vineyard Wind's petition, which has been marked as exhibits VW1 and VW2, the draft environmental impact report for the Vineyard Wind Connector 2, which has been marked as exhibit VW7, and information request responses that bear your name as a responsible witness?
Yes.
And were the information request responses that bear your name prepared by you or under your supervision?
Yes.
And do you have any changes to those materials at this time?
No.
And do you adopt those materials as your testimony in this proceeding?
Yes, I do.
Ms. Hartnett, could you please state your name and business address for the record?
Yes, Maria Hartnett of Epsilon Associates. Our main address is 3 Mill and Main Place, Suite 250, and that's in Maynard, Massachusetts.
And in what capacity do you work for Epsilon Associates?
I am also a principal at Epsilon Associates, and I focus on coastal and marine projects, including offshore wind projects.
And on whose behalf are you testifying in this proceeding?
Vineyard Wind.
And was your resume submitted with the as an attachment to the witness list that Vineyard Wind submitted in this proceeding?
Yes.
And have there been any material changes to that resume since it was submitted?
No.
And did you participate in the preparation of Vineyard Wind submissions in this proceeding, including the analysis to Vineyard Wind's petition, which has been marked as exhibits VW1 and VW2, the draft environmental impact report for the Vineyard Wind Connector 2, which has been marked as exhibit VW7, and information request responses that bear your name as a responsible witness?
Yes.
And were the information request responses that bear your name prepared by you or under your supervision?
Yes.
And do you have any changes to those materials at this time?
No.
And do you adopt those materials as your testimony in this proceeding?
Yes.
So thank you very much. Presiding Officer, the witnesses Maria Hartnett, AJ Jablanowski, and then I believe Ted Barton will form the panel. They are available for cross-examination.
Thank you, Mr. Lang. I believe the questioning will begin this afternoon with Mr. Wong.
Presiding Officer, if I may.
Mr. Gerson.
Just quickly for the record, I'd like to note if we were in the hearing room, we would have noticed that Mr. Aruda and Ms. Johnston have left, so they are no longer here. And then I apologize if I'm wrong, but did we swear in the witnesses?
We just did. Okay. Unless you have anybody else to add this afternoon.
I do not.
In that case, Mr. Barton, you are still sworn, which I'm sure you were aware of. Thank you.
Absolutely.
Ms. Sharkey? It's Jeff Eugenio. Oh, we had planned on exiting the, I'm sorry, we had planned on not participating in day 2 and day 3. So if you wouldn't mind, I think we may bow out for the rest of the day today, Mr. Axelson and I.
Thank you. I appreciate you letting me know.
Thank you. Thanks to everyone.
Mr. Wong, you're still up.
Okay, thank you, Ms. Sharkey. So I'm gonna start with the offshore air impacts, and they're really just one main question. In the DEIR, which is BW-7 at 1045, the company talks a little bit about the requirement for an EPA Outer Continental Shelf air permit. I noticed that the permit isn't in the table of permits for EFSB-G-4 or the table 1-2 of the DEIR. Can the witnesses explain to me how this air permit is related to the other permits, or if it should be a part of these tables? Thank you.
I'll start. I do not have those particular tables in front of me, but generally the OCS air permit is issued by the EPA for actions in federal waters. To the extent that the permit lists are associated with state actions or actions concerning the Commonwealth, that would be the reason for excluding this permit.
Thank you. For your benefit, Mr. Jablonowski, I'm going to throw that table onto the screen if that would help you.
Yes, that would be helpful.
Give me 1 second. So as you can see, it's just a general permit table that has all the permits. Oh, sorry, it's right here. Thank you. So I had a general question about the requirement for the EPA OCS permit to comply with the corresponding onshore area. How would Vineyard Wind comply with that requirement? Like, how does that compliance look like?
Okay. Yes, it looks like an air permit process where the EPA is reviewing and approving the project's documenting compliance with both federal and applicable, in this case, Massachusetts state regulations. So as we submit an OCS air permit application, it will include documentation of how the project will comply with federal rules, but also with the air quality rules, predominantly in 310 CMR 7. So to a large extent, EPA is acting as if it was Mass DEP and reviewing and approving our permit and its compliance with state rules.
So would EPA be using the same rubric judging criteria based to judge the, like, you're providing documentation that's saying that you're complying with Mass DEP, and EPA would look at that in the lens of Mass DEP and judge that criteria, or would you have to go to Mass DEP to get their their blessing and then come back to EPA and say, Mass DEP said it's fine?
It is the former of the two processes you described. So
Okay.
EPA is the permitting authority. Mass DEP is reviewing the process, but has no formal authority in the process. Mass DEP is copied on the tentative, on the draft permit, but we are interacting entirely with EPA.
Thank you. I don't think this was entirely clear to us. Why is the OCS permit required? What bases does it cover in terms of the impacts of the offshore farm and its connector?
Okay. The Clean Air Act has a rather actually unusual trigger for what requires permitting in the outer continental shelf. It's a very specific definition in 40 CFR 55. It needs to be an air emission source that is erected on the seabed and does work. And there's been a considerable amount of effort put into how best to define that set of rules as it applies to offshore wind. The original intent is clearly to have regulated drill rigs, offshore oil exploration and offshore oil production sources. But the definitions stand, and we will have OCS sources that erect onto the seabed and do work in advancement of the project, and therefore trigger the requirement for this air permit.
Thank you. I was gonna get to that, but could you tell me what exactly an OCS source is? Are they treated as point pollutant sources? Could you explain that to me? Thank you.
Yes, they are treated as point pollutant sources. An example is going to end up being a jackup vessel and the engines that are doing work on a jackup vessel. Those have been described in the record, but generally those are going to put feet down, elevate the entire structure up from the seabed, and then start doing something. An obvious example would be driving piles in order to install wind turbines.
Could you stop for just a minute? Sorry, AJ. There's a reverberation in the background. If you aren't a witness who needs to speak, please mute your background, and then that won't interfere with what we can hear, and more importantly, what the stenographer can hear. Thank you. Go ahead. Sorry to interrupt.
It's all right. Mr. Wang, have I sufficiently answered that question?
I believe you've answered that question, yes. And that sounds to me like the OCS permit is more wide-ranging than I had thought. So does it cover air emissions from construction all the way to operation and maintenance? Any sort of point source that might happen in the interim?
Yes, it does.
Okay. And with regard to that, the definition, it says that the state compliance requirement only applies to these sources that are 25 nautical miles beyond the state's seaward boundary. So that would be 28 nautical miles from shore. Is that correct?
Beyond that distance, state requirements would no longer apply.
Mr. Jablonowski, could you try and see if your audio jack is completely plugged in?
We can also try a different way. How is this working?
Much better.
Okay,
Thank you.
so repeating the response there, state requirements would not apply to sources that are beyond that distance from the boundary. That being said, the Vineyard Wind, the original Vineyard Wind 1 precedent will end up treating the entire project as subject to the state rules.
Good to know. Thank you. So it wouldn't matter for this purpose because Vineyard Wind 2 is going to treat the whole project as being applicable, as being state applicable. It wouldn't matter how much of the project boundary is covered by the 28-mile distance. But could you, for the record, tell me, to give me an idea of where exactly 28-mile buffer might cut off with regard to the project?
I'm sorry, where exactly the 28-mile what?
28-mile buffer might cut off at the project, in the project. Thank you. Would it make its way into the wind farm area?
I do not have that distance in front of me.
I believe the distance of the state jurisdictional offshore cable is 23 miles. So I think I can get a good gauge, but if we're able to have a confirmation of that, maybe not right now, but by a record request, that could help.
We can follow it up that way, yes.
Okay, that would be record request EFSB 16.
Thank you. So it seems like, Mr. Jablonowski, if the OCS sources are what's considered, and you said the definition of that is that they have to have some sort of seabed disturbance. Is that what you had said earlier?
Close. The source needs to be erected on the seabed in order to do work associated with associated with the wind turbine project. As a follow-up to your prior discussion, we can certainly continue to look at it as a record request, but a quick look at the figures while we were looking here. The entirety of the project that's in front of you now would be within the 25 nautical mile boundary.
And when you're referring to the project in front of us now, you mean the state jurisdictional offshore cable portion, right?
The Park City Wind project.
Okay, thank you. That's helpful. So getting back to the erect structure for project completion, that would not include a construction vessel that anchors to the floor, to the sea floor, would it?
That's correct, and that's been the topic of much discussion with EPA through the OCS air permitting process.
And this might be covered in the permits, but do you know which federal agency might be looking at the vessel, construction vessel air emission impacts?
Okay. That still is EPA, and it is also BOEM, but I can give you a longer answer on that. The EPA through the OCS air permitting process is regulating the sources, the OCS sources that I described. Through another quirk of 40 CFR 55, when you look at regulatory applicability, essentially whether or not we trigger major source air pollution thresholds, you look not only at the OCS sources that I described, but you also look at vessels servicing those OCS sources. So based on the Vineyard Wind 1 precedent, EPA has taken that to mean they are looking both at the total emissions from the project, including those vessels that are traveling to and from OCS sources. And they are also taking a look at the analysis of air quality impacts. So, for example, air quality dispersion modeling that includes both the OCS sources and the servicing vessels. And then to circle back, we are describing overall air quality impacts through the BOEM EIS process.
Thank you, Mr. Jabłonowski. And one quick follow-up. What does an OCS air permit look like? Is it like a really big filing, like a big voluminous document like a COP from BOEM, or is it more focused than that?
It is more focused than that. Air permits used to be as short as 5 pages long. This one is not quite that short. The final final Vineyard Wind 1 permit was issued on May 19th of 2021, and it clocked in at approximately 40 pages, plus a fact sheet of about an equivalent length.
Thank you, Mr. Jabłonowski. I appreciate that. And finally, you gave a good example of a jackup vessel for an OCS source. I was wondering if you had more examples. For example, a jackup source, I would see that as a temporary structure for construction. Are there any permanent sources due to the project, for example?
I'm sorry,
Yes.
due to the project what?
For example.
The electrical service platforms will have emergency diesel generators. So those diesel generators will be permanently out there to provide power in the event of a power failure. And those would be permanent OCS air permit sources.
Thank you. And so that's all within the federal realm, but within state waters, do you see Mass DEP also having a look within the 3 nautical miles for an air permit?
There will be nothing that will trigger air permitting requirements.
Would the area within the 3 nautical miles be described as part of the OCS permit, or you're only describing from 3 nautical miles beyond within the 25 nautical miles, and based off of Vineyard Wind 1 precedents, anything else that might not be captured?
It's the latter. The EPA's jurisdiction is for federal waters only. So once you enter state waters, it's not part of this permitting process.
Thank you. I'm all set with the OCS and air questions. Does anyone else on the bench have anything to follow up?
I do have a follow-up. It's not for offshore air impacts, but I see that Mr. Jablonowski was one of the respondents for a question about sulfur hexafluoride at the onshore substation. Sort of a basic compliance question. If there were an accidental release of SF6 from the company's substation, is there any automatic obligation to report that to Mass DEP?
The Massachusetts Department of Environmental Protection has reporting requirements associated with 310 CMR 7.72, reducing sulfur hexafluoride emissions from gas insulated switchgear. I do not immediately recall a requirement in order to that there are reporting requirements associated with that. To my knowledge, there are no emergency reporting requirements. That rather makes sense in that there is there's no human health risk associated with NF6. That's not the focus of the SF6 regulations. The focus is greenhouse gas emissions limitation. And so there isn't an immediate risk associated with that.
So it sounds like there is a reporting requirement. It's just not an immediate reporting requirement.
Yes, there is an annual reporting requirement under 310 CMR 7.72, paragraph 6.
Got it. So the company does not have, well, let me rephrase. Does the company need any ongoing operational permit for the substation for the amount of SF6 that's used in the switchgear?
It is not a permit. They have regulations under 310 CMR 7.72 that they are subject to.
Okay, I think I'm all set on that topic. Thank you, Mr. Jablonowski.
So I guess we can move on to the offshore noise, unless anyone wants to make a last minute objection. Okay. So good afternoon, Ms. Hartnett. And I guess these questions are for the whole panel, but referring to that table earlier that I showed everyone, EFSB-G-4, could someone on the panel tell me which permit might directly consider noise within state waters? And I guess for this project, it would be construction noise rather than cable noise.
Yes, I can answer that. And if you'll give me just a moment, I'm trying to get the table open so that I can use the same name that is in that table. Would you mind repeating the table name for me one more time?
It's in the company's response to EFSB-G-4.
G4.
Yep.
All right. I'll take just a moment to get that one in front of me. So the permit that I would cite is the one from the U.S. National Marine Fisheries Service, where we state a letter of authorization or incidental harassment authorization. That permit is focused on offshore noise associated with pile driving, but it does also cover activities within state waters.
Thank you.
And I should also add that as part of the construction and operations plan filed with BOEM, the Bureau of Ocean Energy Management, there is an assessment included in the COP that includes state water activities such as vessel transits, and BOEM provides conditions to protect marine mammals that relate to both state and federal waters.
Thanks, Ms. Hartnett. Thank you. And now I'm going to be talking about the HDD and the related noise. Is that within the bounds of what this panel can cover? Mr. Barton, you're muted.
Sorry. I think it's going to depend on how much detail you want to dig into here. HDD is sort of neither fish nor fowl maybe for this panel, but you know, why don't you start and we'll see how we can do. And if it may be that some of these may need to wait for our land noise panel, which includes Rob O'Neill, but we can give it a try.
Thank you. So I'm generally looking at the company's response to EFSB-NO-15, which describes the equipment used for HDD activities and general noise-related impacts. I'll give you a second to get there.
Yes, please.
And let me know when you're ready to respond.
Yeah, I have that.
Okay, so I think this will be a pretty high-level question. So what is the duration of noise from the HDD activities in general? Is it the duration of HDD construction, or would it be confined to a particular period of time?
Well, so the overall HDD process of setting up the site, setting up the equipment, getting ready to make the drill, doing the drill, doing the pullback, then you repeat the cycle twice, and then breaking down the site is something that occurs over a period of 2 to 3 months, thereabouts. It is daytime only construction work with one exception. And obviously the setup pieces and the breakdown pieces of it are mainly bringing equipment in and then later removing it. So it's sort of in the vein of sporadic truck traffic, loading things using a crane or whatever. The piece of this that is the noisiest is the actual drill itself. So that's an activity that could go on for several days. We do have, I don't have it at my fingertips here, but we do have another response that talks about the duration of some of those sub activities. But hopefully that gives you an idea.
Yeah, it does. Thank you, Mr. Barton. And before I forget, I wanted to thank Mr. Jablonowski for the air question answers. I was done with those. So it sounds like besides the actual HDD construction noises, there's going to be some intermittent trucking noises. And wait, disregard that question. Sorry. Moving on. So in the company's response to EFSB-NO-14, the siting board asked the company to provide distances of receptors from both landfall sites. And could the company describe whether there's a material difference between the two landfall sites based on HDD noise impacts? It appears to me that the distances, at least what are shown, are not that far off for either site.
I would say that's a fair summary. At either location, you're talking about a very small number of homes within a distance of 200 or 300 feet. Some of those homes may be seasonal in nature, others not. But I don't think there's a really significant difference between the two landfall sites in this regard.
Okay. And in that same response, since the company knows the distances from the closest receptors, is the company going to consider, or will it be able to stage materials in particular areas of the site to maximize the construction noise from traffic to these receptors?
So I would say our principal concern in terms of how things are located really is where the drill itself is set up, and there's not a lot of flexibility on that score, because we know our starting point. We know we have to go perpendicular from the shoreline. So I think the noise control there is more a matter of time of day and accomplishing the work as quickly as we can. There was some discussion in the first project about the possible use of basically noise curtains, if you will, to limit some of the noise from the drill itself to one particular home that was relatively close at Covell's Beach, and that is something that we committed to looking at further if it turned out that home was going to be occupied during the time that we would be doing the work. And I think we could look at making a similar arrangement here. So in terms of truck traffic in and out of the site, the truck traffic is going to come on a public road, pull into the parking lot, unload or dump whatever materials it's bringing and leave. So there's not a whole lot that we would do around that activity.
Thank you. With regard to noise curtains, would that be more effective closer to the construction site or closer to the receptors?
You want to put them as close as you can to the source of the noise while still leaving enough room to safely operate and get at the equipment.
Thank you. And for the record, what do noise curtains look like for big construction project?
Well, this is probably a somewhat untechnical answer, but basically kind of like a big heavy blanket, and they typically are hung on construction fencing. So you would be putting up construction fencing in any event to keep bystanders out of the work zone. So if you had a 10-foot, say, standing chain link fence, these noise blankets are basically hung from the top of the fence and they extend down to ground level. And they basically serve to mitigate or muffle the noise to some extent.
Thank you. And is there a separate panel for answering noise for landfall and offshore questions? I wasn't sure if this was too into the weeds for today.
Yeah. So Maria is here primarily to address offshore noise questions, and from the federal perspective, that discussion is largely focused around construction noise and its potential impact on marine mammals. And then we do have a separate noise panel later in the proceeding for onshore noise. The HDD being a piece of it, as well as construction noise from the installation of the duct bank and operating noise for the substation. So that area is Rob O'Neill is our specialty witness on that subject.
Okay, I appreciate the explanation. I might save the rest of these questions for Mr. O'Neill's day. Ms. Sharkey, I can go into fisheries and marine species unless you see otherwise.
Let's as we move ahead, the list will have to make up on Wednesday.
Awesome. So this is a general question, and it might be more construction related. So if you're not able to answer this, Ms. Hartnett, feel free to stop me whenever. But in the company's response to EFSB-F-7, the siting board phrased its question in a way to focus on concerns about offshore cable installation and with regard to fisheries. If you're able to, could you speak to any prevailing concerns with the project in general and not just with regard to cable installation?
I believe I can, but I want to make sure I understand your question. So in EFSB F7, we talk specifically about fisheries stakeholders' concerns relating to offshore export cables. And then was your question about fisheries stakeholder concerns in general? I want to make sure I understand it right.
Exactly.
Yeah, so I think for the portion of the project that is within state waters, which is within jurisdiction, I think what we listed in F7, those are the primary concerns. As we start to talk about the project in general, I do think there are other concerns related to the wind farm, but those are out in federal waters. And I would say they are similar concerns, but you also bring in concerns such as navigation once you move offshore. But for state waters, I believe the list we put in F7 provides a good overview.
Thank you. In the company's response to EFSB-F-17, it states that it could look at how construction duration might affect economic exposure of commercial fishing in its forthcoming FEIR. We've also looked at last week the COP from BOEM, and there is a filing in there that talks about economic exposure. Would the information overlap with each other?
Yes, and in fact, if you were looking at the COP, there is an appendix to the COP with fisheries economic exposure. And what will be in that document was very recently updated. As you are very likely aware, the COP just became public on June 30th, and our fisheries economic exposure analysis was recently updated in preparation for the COP to become public. And so what you will see in the FEIR, it will be by the same author, the same fisheries economist, and it will contain similar material, but we will likely focus it on the offshore export cables.
And I've seen the appendix, but I haven't read it. Could you give us a quick summary of what the findings are within that volume of text?
Sure, and I'm going to take a moment to open it so that I can give you a more complete answer. So if you give me a moment here.
Sure. And if you at any point believe that a record request might make this easier on you, feel free to chime in as well.
No problem. I am happy to just open a document and give you a little summary.
Thank you.
So the document in the COP reviews the available fisheries data, and it provides an estimate of fisheries revenue within the wind farm, so out at the lease area, which is in federal waters. And then it also reviews fishing revenue data, and it provides an estimate of annual fishing revenue along the offshore export cable corridor. So as all of you here know very well, that's the part of the project that is partially within state waters. Then the document also provides an assessment of impacts. So following providing the baseline value of fisheries, it then also looks at impacts. So offshore, it considers impacts to that revenue, including impacts from navigation or congestion, impacts to shoreside processors, et cetera. But for the offshore export cable installation, it considers impacts from construction. So it describes the anticipated duration of construction. It describes the anticipated effects to fishermen. So it describes how there will be a cable installation vessel moving along the export cable corridor and how there will be temporary effects to fishing. And then it works to assign a dollar value to those effects.
Thank you. And with regard to the temporary effects, would that completely disallow these fishermen or these fishing operators from making their livelihood, or would that just be that they have to reroute extensively due to the project?
Yes, so the report considers that there is a temporary area that is unavailable for fishing. And if I may, I'll take a step back and talk briefly about cable installation. So as many of you are likely aware, during cable installation, there is a vessel and other support vessels moving along the offshore export cable installation corridor and installing the cable. For those vessels, we do anticipate that there will be a safety zone. And so essentially there will be a moving safety zone traveling along the offshore export cable corridor. So at any given time, there will be a limited area where fishermen are asked to stay outside of that safety zone. And so the report looks at that and calculates those areas and durations of time during which fishermen will not be able to fish in these areas during construction.
Thank you, Ms. Hartnett. I don't have this off the top of my head, but could you state what the duration of disturbance was estimated to be? Does that just correspond with construction time of the offshore cable?
It does. For the purposes of the fisheries economic analysis, it is looking at construction disturbance. And the reason for that is following construction, the entire offshore export cable corridor will be open for fishing, and the cable burial depth has been designed to be deep enough to allow fishing activities to continue to occur. So we don't really expect any impacts to fishing during operations, with a limited exception of maybe if cable protection is there, that might be an item that fishermen need to be aware of. So during operations, we are not expecting effects along the offshore export cable corridor. During construction, there will be temporary periods where either cable laying vessels or other support vessels or other activities like surveys are occurring. And in this analysis, I believe we assumed a period of approximately 9 months. And in the analysis, we explained that that period, it won't necessarily be 9 continuous months, but when you consider all of the activities that are part of cable installation, we tried to be conservative, and so we assumed about 9 months of activity.
I should have done this earlier, but we are talking about Appendix 3-N of the COP for BOEM. Is that correct?
Correct.
Thank you. And one last follow-up on your answer. You mentioned that if there are cable protections, the fishermen in the area should take note of certain precautions to take. Could you briefly describe what type of precautions those might be?
Sure, and I think this ties into your earlier question when you asked what some of the concerns were. And we identified that one of the concerns is related to gear snags. And so there is a concern that if there is cable protection on the seafloor, that for certain types of fishing gear, it could potentially lead to a snag. And Vineyard Wind is putting a lot of thought and effort into minimizing cable protection. But in the event that some is needed, there will be a new feature on the seafloor. And so we expect that depending on the gear type, if fishermen are operating gear that interacts with the seafloor, they may want to skirt around any areas with cable protection.
Thank you. And moving on, in company's response to EFSB-F-13, it provided some examples of time of year restrictions used in Vineyard Wind 1. It wasn't explicitly stated that these might also apply to, I think it was implied, but rephrase. So does the company expect mostly to have to use the same time of year requirements for this project as well?
We do expect that the agencies and developers are continuing to learn as these projects are being permitted. And so at this point, while there was a time of year restriction for Vineyard Wind 1, there is not at this time a cable restriction for Vineyard Wind Connector 2. And so that is something that we hope to further discuss with the agencies and with BOEM as we go through the permitting process. As my colleague Ted mentioned earlier, the state process is ahead of the federal process. For the federal process, it is a 2-year process that just kicked off on June 30th. And so we expect that on both the state and federal side in the coming months, there will be many discussions about any appropriate time of year restrictions.
Thank you. And within the state process, could you list the agencies that might have an interest in delimiting these time of year requirements?
Sure, I'll start and then I'll ask my colleague Ted to make sure I'm not forgetting any. So I would expect that Mass DEP would be involved. For Vineyard Wind 1, it was the 401 water quality cert that listed that time of year restriction. And they consulted with the Massachusetts Division of Marine Fisheries to develop that time of year restriction. And also Coastal Zone Management was involved.
Just to build on that, in the response F-13, the first paragraph of this actually is talking about the piping plover, a bird species that is found in beachfront areas. And so we would expect that we would have a piping plover protection plan that will look a lot like the one that was agreed to for Vineyard Wind 1. And that is driven and negotiated with Natural Heritage and Endangered Species, which is a program out of Fish and Wildlife. And then there's also a provision mentioned at the end of this response that talks about tree clearing restrictions that are intended to protect the nesting habitat of the northern long-eared bat. And that actually comes out of U.S. Fish and Wildlife, and that we would expect would apply as well. But I think what Maria covered in terms of the cable installation time of year restrictions was spot on.
Thank you. And largely the federal piece of it would be for the wind farm installation and not for the cable. Would there might be a little overlap. Can you speak to any agencies that might be involved with that piece of the review?
Yes, sure. So as you've seen on figures in the DEIR and elsewhere, part of the offshore export cable corridor does fall within federal waters. And so BOEM, the Bureau of Ocean Energy Management, does look at that. BOEM does have a biological component of their review. They have fisheries subject matter experts that review our COP and look at things like time of year restrictions. And then BOEM also consults with the National Marine Fisheries Service. So I would expect both of those agencies would be involved in evaluating the project.
Do they have a hard jurisdictional cutoff in what they review, or is it a little more amorphous in how they consider impacts?
That is an excellent question, and it is one that comes up during BOEM's review. So BOEM's review is focused on the portion of the project in federal waters. For example, BOEM for Vineyard Wind 1 granted a legal easement for the offshore export cable corridor, and that legal easement is only for that portion of the export cable corridor that is within federal waters. At the same time, as you have all seen from the figures, the offshore export cable corridor goes in and out of federal and state waters. And so for that reason, when reviewing the project, BOEM does take an overall view of the export cable corridor in both state and federal waters. So the maps we provide of fisheries resources are for the entire offshore export cable corridor. So BOEM does look at the whole corridor, but again, they do have their specific legal jurisdiction to federal waters.
Thank you. Moving on to the attachment 1 of EFSB-F-15. The company presented us a graph of mapped sites for the Massachusetts ocean management planning areas. Does that sound familiar?
Yes.
Okay. So it looks like the contours of the mapped area hug pretty closely to the coastline. And is that because it only considers the 3-mile state jurisdictional area?
This was something that came up earlier when Holly was describing or commenting on the usefulness of some of the earlier cable routing recommendations that came out of the ocean plan. And as you can clearly see from this map, the mapping is restricted to state waters. So there's the donut hole in Nantucket Sound, and then the federal waters to the south of the islands that are not included in this mapping scheme. So because they focused on state waters, the stuff shown on the map is by definition close to the coast.
Thank you. Does the company have access for its own planning purposes to a map that doesn't cut off that state waters, that ostensibly might extend all of these resources out to federal waters as well?
So we don't have an exact corollary to this for federal waters, but we've obviously done a lot of work to study the offshore export cable corridor, which, as we've discussed, is in both state and federal waters. So for portions of this area, we have very extensive data and studies, and that's been provided both at the federal level via the COP and also a set of maps that have accompanied the MEPA filings.
Thank you. Could you provide me the figures for the MEPA maps, if that's at the tip of your fingers?
I don't have them memorized like Holly and Maria do, but we can certainly look them up, and at a break I'll give you the number.
I might be able to help you out, Ted. I think you're talking about the Vineyard Wind Connector to DEIR, and attachment C is the OECC map series that includes the hard bottom mapping. That is what you were referring to, correct?
Correct.
Thank you. So this is a more general question related to this map. Are the requirements in federal and state regulations similar in that they they want the company to avoid certain areas or to avoid certain animal populations? Is it pretty much the same, or are there quirks that might distinguish the two from each other, federal and state regulations?
I would like to take a first answer to that, and I will start because on this, I will break my response into two parts because this map is showing two things. So I'd like to start by talking about the whales, because as you've been asking about, this map shows whale populations. And you have been asking if there's a difference between the state and federal processes. And in the ocean management plan, what it notes for mapped areas of whale habitat is that there may need to be a time of year restriction if the seasonal presence of the whales warrants that. So I do want to point that out, that different species of whales may be in this area at different time periods. They aren't necessarily here year round. And I would say that that general concept of understanding the densities of the different whale species and understanding the time of year when they are present, that is broadly consistent across the state and federal processes. And in the federal process, both with BOEM and NIMS, there is an extensive evaluation of that, and there are extensive conditions put on the project in order to be protective of whales. Just to give you an example, we very recently got what's called our COP approval from BOEM. It's an over 100-page document, and 30 or 40 pages of it are devoted to marine mammal protection measures. So they are significant. So I think I've answered your question related to whales. And now I wanted to move on and answer your question related to one of the other features, which are the seafloor features, such as eelgrass and hard and complex seafloor. And I would say that both in the state and federal processes, that these are recognized as valuable habitats. And so during both processes, these resources are fully mapped and evaluated, and then mitigation, avoidance or minimization and mitigation measures are developed.
Thank you. Thank you for the comprehensive answer. And I was just double checking that the map series that you had quoted to me for attachment C in the DEIR filing, that includes both the mammal aspect and the seafloor characteristics. Is that correct?
I'm taking a quick look. That map series is focused on the seafloor characteristics, so things like the eelgrass and the hard and complex bottom. And I'm taking a quick skim to see if it shows. I do not believe it shows the ocean management plan mapped core right whale habitat.
So the ocean management plan mapped what?
The ocean management plan mapped core right whale habitat.
If you look at, Maria, if you look at the key sheet for that map set, I see at least one or two areas of the right whale core habitat mapped.
Okay, I'll correct myself then. I think I'm just looking at it quickly and I missed it. So please go with Ted's answer then. Oh, yes, Ted, thank you. It's jumping out at me now. So again, let me correct my previous statement. On the overview sheet, it is very clearly mapped there.
Thank you. While we're on the topic of whales, I wanted to get for the record, how are whale traveling habits related to these mapped areas? You had mentioned that there might be some time of year, they might be seasonal. So how do they travel? And if they're not seasonal, do they just stay within these neatly formed boundaries, or what exactly does that look like?
I do not believe the whales are aware of the neatly formed boundaries. I do not believe they have been informed of them. So, so we can't guarantee they stay within them. But it's my understanding that the ocean management plan mapping used observer data. If you'll excuse me for just a minute, I might be able to find it, but in the ocean management plan, they talk about the data source that they use. And so it's a data record for a period of years. Yes, I found my notes. In the ocean management plan, they say they use sightings data from 1998 to 2014. And so what I want to mention from that is it's my understanding that they use that data, and there are some areas where the whales tend to congregate, where they tend to be better habitat. But it's also my understanding, and so I believe that is what led to certain areas as being mapped. But it is also my understanding that many of these areas are just used seasonally, and it does depend on the different whale type, but it is my understanding that many whales are migrating north to south and feeding, and so they are only in a given location for a certain part of the year.
Thank you. And with regards to the seasonal migration, I know you might not be a whale expert, but would the prevalence of sighting of whales be related to whether they have food in that area, if there's like their prey is there, or
I'm sorry, if like what?
If, for example, there's food in the area, or if there's prey for them in the area.
Yes, so I will definitely say I am not a whale expert, but that is my understanding, is that whales are feeding or that the seasonal presence of whales can be related to the presence and abundance of food, and that there are certain months of the year for each species when they are likely to be present, and other months of the year when they are well to the north or well to the south of this area.
Thank you. One last question on the whales. In my reading of the company's response to EFSB-F-18, the company seems to say that whales can easily be avoided by vessels. Could you explain the basis of that statement? I will look up the exact sentence if you need me to.
Sure, I will take the reference to the exact sentence if you have one.
So I guess
there's a list of guidelines in the second paragraph. Is that what you are referring to, Mr. Wong?
I think I'm referring to the last summary paragraph, which is saying that Vineyard Wind's vessel operators and crew will maintain a vigilant watch for marine mammals and will slow down or maneuver their vessels as appropriate to avoid potential interaction with a marine mammal. I My perception might be misinformed, but that you might see a whale and it's too late to make any maneuver or slow down. But that sentence seems to suggest that it's possible to do that.
Yes, it is my understanding that that is possible. And Vineyard Wind has already had a considerable amount of experience with this. Vineyard Wind has done a significant amount of offshore survey work, and there have been offshore survey vessels. And Vineyard Wind has requirements to maintain watch for marine mammals, and they have protected species observers on board. And it's my understanding that those efforts have allowed them to either avoid or minimize any interactions with marine mammals.
Thank you. That's helpful. Go ahead, Mr. Barton.
I was just going to add a point of sort of color commentary to this. This is an area that the project has put a lot of thought into, but for the piece of the project, the primary piece of the project in state waters, cable installation, it's probably worth pointing out that those vessels move very slowly. It talks here about reducing vessel speeds when you sight a whale to 10 knots. So the cable laying vessel is probably traveling at a speed of more like 1 knot. So the whole operation moves very slowly and hence doesn't really threaten the whales in the same way that a rapidly moving ferry or other vessel might. So.
Mr. Barton, if you are able to, could you estimate what 10 knots is in miles per hour?
Well, let's see. It says here it's 18.5 kilometers per hour, so that's probably about 12 miles an hour.
Okay, thank you.
Yeah.
Ms. Sharkey, I have one more question on the mobility of animals. Should we ask that and then you can do cleanup if you would like for the day?
Certainly.
Thank you. So in the company's DEIR at 9.4, I'm just going to describe what I read, but you can take the time to get there and let me know if you need it after I'm done. But the company explains how mobile animals, quote unquote, mobile animals could swim away to avoid construction of the offshore cable, while slower responding ones would then be subject to risks related to this vessel traffic. Could the witnesses give me an example of either category of these animals, a quote unquote mobile animal and a slower moving animal, or a few of them, if you can?
Sure. Mobile fish in the water column, let me come back to that. We think a lot about immobile species. So that would be, or species that live on the seafloor. So for those, we are often concerned about juvenile stages. So things like winter flounder eggs or squid mops, those are attached to the seafloor. Shellfish, most species of shellfish are in the seafloor and don't move away very rapidly. Other fish that could move away more rapidly, anything swimming in the water column could move away.
Thank you. And you'd mentioned that the slower or immobile species are essentially stuck there. So what are common mitigations proposed for these animals if you had to go through their habitat?
Sure. So the mitigation for immobile species is often commensurate with the level of impact. And again, for many of these species, the impact from cable installation is a 1 meter wide swath for each cable. For dredging, it could be a little wider, up to 20 meters, but these species are all present within the larger part of Nantucket Sound. And so we have seen, and I know there are several record requests on this, that given that relatively speaking narrow impact, that these areas do recolonize. And so given the expected recolonization, the mitigation plans have more been focused on monitoring and confirming that these areas recover as we expect them to.
Thank you. And this form of monitoring is, correct me if I'm wrong, described as benthic monitoring?
Yes, or benthic habitat monitoring, correct.
And that would be in a benthic monitoring plan. That would be outlined in a plan such as a benthic monitoring plan. Is that correct?
Correct.
Thank you. And finally, if monitoring shows poor recovery, are there any recourses for that swath of land, or is that just, based off, if it's commensurately small, then it's just fine?
Well, I want to start by just stressing, so as we said in the DEIR on that same page, that there is not yet an agreed upon benthic monitoring framework. That's something that we expect to develop as the project proceeds through review. But in terms of mitigation, the studies that we've seen from Block Island, European studies, and elsewhere have all shown, or even we reference here as well, the Martha's Vineyard hybrid cable, those have shown recovery. And so given that the agencies have focused on a monitoring plan, but I do think there's always a provision that if recovery is not observed, then additional consultation can occur to determine next steps. But the available evidence all suggests that recovery will occur as expected.
Thank you. I'm all set for today. Mr. Green?
Yeah, just a quick question or two about the cable's impact on the seabed. So we've heard a lot today about different cable technologies, and one of the issues that seems consistent across the cables is the generation of waste heat, given losses in the energy transmission process. And I'm wondering, at the depth that the cable is intended to be buried, whether there is any sort of thermal signature that one would see on the seabed itself in the location of the cable trench.
So somewhere in this vast record, that question actually has been asked and addressed. And Maria may have a better memory of the exact number, but we basically did a calculation of temperature, the incremental temperature change at the sea bottom directly above a cable operating at full load. And it was something in the 100th of a degree Fahrenheit in ocean water that over the course of the seasons can cover a range of 30 or more degrees Fahrenheit. So we concluded that that was really insignificant to immeasurable.
And
I found the reference. Oh, I'm sorry to interrupt. I found the reference.
Yes, if you would.
It is in section 8.2 of the DEIR. And there may be another location as well, but this one describes an evaluation in the Rhode Island Ocean Special Area Management Plan. And in section 8.2, we include this quotation. Studies on the effects of radiated heat from buried cables have found a rise in temperature above the cables of 0.34 degrees Fahrenheit and an increase in the temperature of seawater of 5 zeros and a little bit more. I'll let you look that one up. And then it concludes, this is not believed to be significant enough to be detectable against natural fluctuations.
So the number there was 0.34 degrees Fahrenheit at the seabed surface.
Yes, and in the seawater, it was, again, I'm sorry for that, 40108 degrees Fahrenheit. So
I'm sorry, 40.
Yeah, 0.0000108 degrees Fahrenheit.
And I presume that the degree of temperature change, no pun intended, would increase as you get closer to where the cable is actually buried. Would that make sense intuitively?
It would, and I would also, however, add that my reading of what Maria just quoted, it says temperature directly above the cable, and it's not clear to me that that necessarily means at the sediment water interface, or if it in fact is talking about the sediment directly above the cable. But nonetheless, it's a very small number.
I'm sorry, and is there a number in the response that you can reference? Again, below the surface of the seabed surface.
I don't have that immediately available.
That's fine. Assuming that the temperature increase below the surface of the seabed is greater than the 0.34 degrees Fahrenheit that we were just discussing, do you imagine that there would be any marine organisms that could be affected positively or negatively by that amount of a temperature increase?
I don't believe so. I believe it's minimal enough, and I am not aware of any evidence that suggests marine organisms would be affected or in fact have been affected by temperature changes related to subsea cables.
And
if I'm,
go ahead, Mr. Gerson.
well, with apologies, Mr. Green, I do know that Ms. Hartnett is being kind, but she has another commitment this evening. I believe it may have something to do with BOEM, actually, that we told her we would let her go at 5.
All right. I think my questions have been answered, so that's fine.
And I believe, Mr. Gerson, she's scheduled to be back on Wednesday, along with Mr. Aruda and Mr. Rodstrom and Mr. Barton. Is that right?
That is my understanding. I don't have the schedule immediately in front of me. I believe that's correct. And again, apologies, Mr. Green, but you are welcome to continue your line of questioning when we have her back.
All right, we're good for now. Thank you.
Okay, well, it appears we have mostly run through the topics we were due to address on our second day of hearings. But on Wednesday, we're resuming with offshore environmental impacts with the panel I just mentioned. So, and in light of Ms. Hartnett's scheduling constraints, we could resume on Wednesday at 10 o'clock as scheduled, and address any remaining questions people may have with regard to fisheries and marine species.
Thank you, everyone.
Thank you. Off the record.
For those that might be interested, tonight is the first of the BOEM scoping hearings on the recently made public COP. So it starts at 5:30, and Maria is giving the project presentation. So that's why she was anxious to get underway and be on time for that. So.
I do apologize. I tend to be in favor of getting as much done as long as we can, but I did promise her we would let her go.
And we made up a lot of ground today, Mr. Gerson, so we appreciate that.
Well, we appreciate it as well. Thank you for being efficient.
Is there anything anybody needs to bring up? We're not on the record, but is there anything anyone needs to bring up before we see each other Wednesday morning?
We did have one question about one of the record requests, and we can do this on the record on Wednesday as well. But I think it was a little unclear to us looking at the transcript. I believe maybe Adam or Aaron can correct me if I'm wrong, but I believe it was record request number 8, where there was a request for the COP and indication that we were going to be more specific about what was requested. And then I'm not certain we were ever clarified whether the request had been made more specific or not. Obviously we'll get you what you want, but that was the one question that I had logistically.
I appreciate that. We'll take a look at the transcript and see what Mr. Brock was able to take down from us. And if we need to clarify, we'll do that on Wednesday.
That would be fine.
Anything else?
Me.
Okay, thank you. I look forward to seeing everybody on Wednesday morning.
Thank you very much.
Thank you all. Take care.
Bye, everyone.